here so that way they have the perfect angle. I have noticed using strong rubber bands, for example 3-inch silicone bands, are a little bit too strong, and this piece here will start to warp. I'm only printing in PLA at 50% infill. I even tried PETG and it worked, especially in the side. So my recommendation is either increase the infill, maybe make it stronger, or what I'm going to do is use a less strong rubber band or a longer one, so that doesn't happen. So just keep that in mind when you're printing this and you're choosing your rubber bands. You do want this block here to be strong and not under a lot of force. It doesn't need to be a lot of force. Just a little tension is all it's needed. Alright, so once you have everything printed, you should have 4 of these wire arm spreaders. And if you notice, there's 3 that have this end, and only 1 with the 2 holes in it. So you want 3 of these, 1 of these, 1 for the center beam, and then 2 for the part that pulls out. And then we have a couple wire spreaders and then a part for the P-point. So what we'll start first is with the center part. And what you'll want to do is I have these 3 by 3 millimeter ball pelts. They're very tiny. And on Amazon, when you're looking and ordering these, let's get a couple of these out. They're very small, you can see here. You only need 4. And when you get these, they'll have a rating, an end value. And the end value, the higher the end, the harder it is to push that down. These are 10 ends. I wouldn't go wider than 10. If you see an option for 15 or 20, if they even make them that strong, definitely go up a little bit, just because it will help keep this more rigid. You know, it's going to snap it into place right here. So each side, if you look carefully, try not to pick up on camera, there's going to be a little lip, and then on the other side, a little lip, and that's to counteract this little flange at the very top here. So it should fit in when you put it all in, flush. So what I do is, I just get it kind of started, try to push it in there a little bit, just to where it sticks. So I can flip it over and I can just push it in. There you go. And I didn't glue it. I don't think they're going to snap out. They're in there pretty good, but it's going to be flush. The only thing that's sticking out is that ball. If you can't get it all the way flush, it's okay if it sticks out a little bit. Alright, so let's do the other one. Just take your time. Try not to lose these. So you will drop one and it will be gone in the garage. I'll never find it again. Here we go. So one side's done. Now the other side, we're going to have to flip it, because this will go on this side. We'll have to flip it. So. And if you have any remnants from your 3D printer, little chunks or something, it might not fit, so you'll have to make sure your holes are clear. That one went down actually pretty well. Never had one going that easy. Yeah, let's try the last one. Tweezers not very fun. Pretty small parts. There you go. Alright, so step 1 is paint. And the next step are these Chicago sheets, 5 by 7 millimeters. And what these are, you have for the rivet range. Inside the thread, and you have a screw that goes into the end. And so what we want to do is the end that has the balls, the little ball screws. You want to put this that way. all you have to do is line it up. And again, if these holes are really tight tolerance, if they've got a bunch of birds or anything on them, it's going to be hard to get it in. You just line it up and give it a good push. And there you have it. So that's that one. Now the other side is the opposite. So gotta make sure the plunge ball is up. Okay, there's the back side of that side. And line it up. Push. Okay. So our center piece is done. Later on, I'll show you that one, but part of the ride is done with that. Now for these are the ends that will go on the center part, and the pivot, the close. And I like to put these on first before it goes. So for this, we just grab two, and see the little tab block that's facing up. And so we usually just do one at a time first to get it started. Just push it in, and then a little bit, and push your bullshit. And just be careful not to overdo it and break your 3D part. If it doesn't go in all the way, you might be able to throw a little screw in and close that gap. Alright, and so now, for these, I like to start with your preference, but I like one of the holes to be opening up on the right, because this is where we hook our wire that will go for a feed point, one of the driven element wires. And then for this hook part, that needs to be on the outside, so flip it around, so that way when it opens up, we have the other side here, and we can hook it up with the rubber band. So, hook on the outside. Alright, just line it up. Start pushing on. Okay. You see that one came out a little bit? I'll tighten it up with the screwdriver here. Okay, so the other side, hook on the outside. And just kind of get started. And then I go to the screwdriver. Okay, screwdriver. So, I'll just put one of these other screws on. And at the end, after we get everything built, I'm going to use some thread lock, because I have noticed that these, over time, are kind of useless. And so I'm going to try some thread locker on this build, just to see if that will help keep it more in place without coming out. And so now I'm going to use the screw to bring all the pieces together, because there was a gap. Now I like to tighten down as hard as I can, and that's the plan when I do that. So put the thread locker on, but just double check before you all put the thread locker on and have everything on with it. So you open it up, and you should have hook. Okay? So now that that part's done, that last kind of spread these out of the way, and put it in on the center part of this one. So we'll line it up, just push it down, and we'll screw. It's really hard to do this with the camera, right? Tighten that down. And so now, if there was a ball from your springs there, kind of got this nice little tactical feel to it. You can probably hear it click, barely. And that's most of the frame. And so, if you didn't have these ball plunger springs, you can go without it. It's optional, but I think it's a very worthwhile to order those and put them in, because this is locked pretty good. It takes a little bit of pressure, but really, if you didn't have it, it would just so the loose units will just flop around. So adding that really helps with the stability. Alright, so let's do the other side. The same thing. Tab up. Get her 2 Chicago screws. Get it started. Disengage. Take some force. Okay. Now, do this. And the same thing. Put it on the outside. Sometimes this can be very stubborn to get started. So you want to check the hole, make sure there's nothing in it. You might have to get that one started with a screw. Same thing with this one. Hook on the outside. Try to get this in. We'll come back to that one. Alright, so about that, I'm going to put a screw in this first. It's the other side, it's kind of stubborn. Nice and tight. Okay, now for this, I think I'm going to try. Let's see if I can get it in a little easier with the screw. Use the screw to force it in. There we go. Ready? Ready? Alright, see, that doesn't work. So let's just go back to trying to push it on. If it's really stubborn, like this one would be, just want to double check our hole. Looks like there's a little gold here. So I'm going to clean that out before we come back to that. So we get that out. Alright, so after cleaning the hole, like it's still stubborn, you can't get it in. Sometimes you can use pliers. Use the back of this and just carefully get as close to the surface as you can. Just push down a little bit. Sometimes you can get it in. Yeah, this one is super stubborn. There we go. So we got it out. And I think it's because this wire, the front wasn't the best, and the back side kind of doubled. So that was the reason why it was giving me trouble. The other ones were really good. So, be patient, don't rush it. You want to spend more fuel printing more parts. Now just tighten that again. And we got everything on there. And then for this side here, I'll have to free it. Put it on. Twist down. Get our last screw in place. Try your hard with the camera in the way. And you just tighten it all the way down. Okay. Alright, so now, just for the test, you can see how it all built correctly. And you can close it. So you have a nice compact frame. And then you should be able to open the tin. Have a hook here for your bands. You should be able to put it. You should lock into place somewhat. Pretty sturdy. And you flip it around. Open up the other one. Pretty sturdy. And then open up the other side. So you should have the hook. It's a nice big frame. So that's for the frame part. Now we just have to work on doing the wire. But I want to give you one quick pro tip. If you ever need to take these plunge spring things out, obviously you have to take these off. And then on the back side, where it isn't the ball part, you can use like a small allen to push them back. if you didn't hear one. Don't use anything sharp scissors, sometimes it can get stuck in there and you're going to stab your hand. So use like a little Allen key in the glove. You can get those out without hurting yourself. Alright, so let's go put some wire. Alright, so for cutting the wire, obviously the next tool is to cut the wire. And the tape measure to measure the wire. I also use masking tape or duct tape in this case, so that way when I string my wire out, I can hold it on the table and use that tape measure or ruler, spooler, whatever you have, just to keep the wire from sliding. I can get a much more accurate cut that way. So, nice little test for you. And this is the wire that I'm using. Different wires may work, but the velocity factor may be different if you change the dimensions. So, I would just stick to this brand. It's super cheap on Amazon. Silicone wire. It's really nice and flexible. It doesn't wear out easily or anything. And I'm using 22 gauge. And you could possibly go with the lower gauge. It might not change the dimensions too much, but all of the holes that I have made for this brand are for 22 gauge, and this is the only gauge that I'm testing. So stick to this one for the go, unless you want to turn it. So what you want to do is cut one wire at 38.081 inches, or 967.26 millimeters. And just try to get as close to that number as possible, because that's the final length for the reflector. For the driven element, you're going to cut 2 inches at 19 inches, or 486.6 millimeters. And we're going to trim that down after we get the wire re-printed on that will connect for the implant. So just cut it a little bit longer than at 19 inches, and that will be plenty of length for us to trim it down. So let's go ahead and get some wire cut. Okay, so now we'll put in some wire. Reflector wire. I'm just going to move it down and cut it. Do not touch ends. Leave the insulation head fingers. We just put it off to the side so we need to get for our two roughly cut 19-inch driven elements. You're going to take only on one side and remove the insulation. And I just remove a little bit, maybe a quarter inch or so. Just going to eyeball that. Yeah, about that much. Quarter inch. And we're only really wanting enough insulation because I'm going to solder that into a ridicule. So just remove the insulation on one side of each wire. So your next step is just to solder this on the ridicule. And what I like to do is just come out where it's pretty much flush with the end here. So right about there. And if you go a little longer, that's okay. It's fine. I just put a solid really good. I don't even punch this down the temper. I just leave it as is and just throw up the solid. And so you just do that on each side of the ribbon over there. Get that soldered on, and I like to use the non-insulated ones just because it's easier to solder on, it's less bulky. And then you can always add heat sinks to that later if you wish to solder it. Alright, so now we've got our ring terminals soldered on with a little bit of heat sinking so we can get the little clear. And the next step, if you want to trim this now, what I like to do is just put it on a little bolt so that's something that holds one in. Make sure it's not like this, and make sure they're even. And what you want to do is measure from the end of that terminal to the end of the wire. And you want to trim these two ribbon wires to 17.793 inches or 451.952 millimeters. So just take one end, bring it out, we're going to put the ring terminals to the end and trim it. You want to be as exact as possible. Alright, so working on the feed point, we have that piece, one of your driven wires, and the wires here are driven element, and some hardware. This is stainless steel M 2.5 millimeter by 10 millimeter long, and I will have a washer put on there, and so we'll feed it through one of the holes, and then we'll take another washer, put that on there, and then a lock washer. We don't want these to come loose. Put that on, and then net. These are really, really small. Okay? And then just hand tighten it for now. And then the other side, same length, same size, has a washer on already. Feed that through. And then take a ribbon limit wire, put that on there, and then another washer, and then another, you're going to put on a lock washer, and then another net. Okay, and then just take some pliers and a screwdriver, tighten these nuts down, so we don't want them coming loose, and then we want these no donuts. And what we'll do is we'll have it all strung up, the other driven element will sit on there, and then we just choke, and then we just use this to hold it all together in a nice, slick little cinch. Like so. Alright, so now that our feed point part's all done, let's get our frame all wired up. So the next step. Okay, so for our next step, with the frame, there are the wire splitters, a couple of bands. These are 3/8 silicone bands. The regular rubber band from opposite works just fine. I find these a lot more durable and don't lose their stretch. With the regular rubber band, it seems like they just stretch and don't have that much strength. So, a little upgrade.
I can't hear you very well, John. Are you going to turn your amp on tonight? No, you can't hear me, you prick.
Two pieces of 1/4-inch diameter heat sink. And so what we're going to do first is set up our anchor point. So the wire frame has the 2 holes in it. This is our anchor point. You see all the other ones have this. This is so we can have an anchor spot so that when every time we open this up, it stays in all the elements come through. So what you're going to do is take the ribbon element that has the feed point on it, and we're going to feed it through the top. And I'll show you why in a second. So we'll feed it through the top and the right nice hole. And feed it through that and just feed it back to the hole. Whatever that is. Okay? And you only want 3 or 4 inches. And the reason why we fed it to the top rather than to the bottom without for the further is so that when we fold it up, you see how we only have a little bit of wire now on the bottom instead of all of this, so it just packs it up. Alright, so the next thing is open this up and use one of the bands to hold this open. Okay, you can see both bands, which is the top. There we go. So now our frame is locked in place. The next thing we're going to do, take the wire splitter part, put our big one over there, and just grab a little bit, just roughly, feed it through the other hole, and we only want just a smidge, a little bit
My stupid strength is a 9.
just a little bit. And that's just really make the shoulder. If you do too much, then it might throw off the measurements.
It's a 5'9".
The next thing, first you throw a heat shrink on there, and at the end, if we're done measuring everything, heat shrink it right on there where the wire can place it down. Just throw it off to the side. And then the next thing we want is a reflector wire. And I like to match what we did here, so we're just going to put the bottom on this side. Lock it in place in the other hole. And the same thing, just a little bit there. Not a whole lot. Just enough to help hold it in place. Okay, so that's that. And now then, another thing to note too, see how we're going over the wire on here? And you could wrap it on the underside, but I like to try to match. So I just put it on the sides. And we're going to open up the rest of the front. This stuff's going up to the sides, get in the way. Open everything. And then with this side, put the other band in. Just to lock our frame in place. Alright, so that's it. Try to get this all straight as we possibly can. Now we're going to take the reflector wire side. Bring it down all the way to this end. And since it came through the bottom, get back to the bottom just to be consistent. And we're going to do the same thing as for the outer wire spreader. Move it through. Just have a little bit sticking out, just like the other side. Okay. Now we're going to put our heat shrink on and just throw that out of the way. Okay. And then we're going to take our driven element, the other side that has the terminal, and we're going to take the non-terminal to watch it, so it goes to the bottom, and I'll put it to the bottom on this side. There we go. And the same thing, just a smidge, just a little bit sticking out. Okay. And on this side, it's kind of to the top. Just bring it to the top. And then we're going to turn to our screw point. And we're going to try to make sure all that's straight. And then we'll take one of these little nuts off. And if you have some slack, try to slide this in out. But if you have some slack on this side, you can just tighten it a little bit. Just keep it taut and work your way on the other end. It's just really hard to do and try to keep things in camera in a small spot. But shooters will link those up. Put the middle nut on, keep everything all out. Alright, and then do your best. Hard doing this all on the ground on the table. Make sure these are locked into place the best you can. If it starts pivoting like it is now, it means the wire is a little bit too tight on that side. So you can loosen it and try to get some slack where you can to alleviate that stress is fully over. And once you have that straight, what we're going to do is on the driven side, so this is our driven wire, what we're going to do is take a tape measure and measure from, sorry I got this angle here, we're going to measure from the corner there to here on both sides. And the side that we locked into place here, same thing, from the corner to the end. And we want these to be equal. So this side and the other side is equal distances. And if the inside, this is too long, for example, You gotta shorten it, just pull some wire back through all the slats, and get it adjusted. So that's what I'm gonna do now. Alright, so here's a better look at the frame. We got this all straight. We have everything put together. And if you can see, we have a ribbon element right here. And I'm gonna measure from this corner to the end of the wire spider, and then the same thing from this side to the wire spider here. And you can see they're way off. So what I need to do is take more slats back on this, so that way this will move down a little bit, which will make the wire out. So you're going to want to do that to make it all even. So I just got everything adjusted again, from that corner to there. So you can see, use the ribbon on that side, not the reflector side. And then from that corner there, and I got that pretty much strong out. So the next thing we're going to do now is finish our two-point by creating the choke. Alright, so before we start building this pattern, this choke, I just want to pull out this document here from K9YC. This is a great reference document to have and very good read for patterns and chokes. So this is where I'm getting my information. So definitely check that one out. And what we end up doing is we're going to use some RG316 coax and some polaroids. And we want to measure that narrow DNA, so I'm going to show you how I do that. Putting the narrow DNA into the computer and then building a build-up so we can do measurements. But what we're going to be trying to do is to build our choke that has a resistance of 500 to 1,000 ohms or better. And that should be sufficient according to this documentation for DHF. HF, I think we'll mark this up to be 3,000 to 5,000. So DHF is a lower S, which is good because we're not getting higher. It's like so, total rates, kind of a lot of different materials. 43 is a pretty common one, 30 down, I'm sure you've heard of these. What I would do is 60. Now, if you have 43 or 31 here, measure your choke, they highly encourage you to test that and experiment because you may make a better choke than that. So I just got some type 60 millimeter. But with that being said, on top of measuring our resistance from 500 to 1,000 ohms or better, we still want to choke if it wasn't 2 ohms. So we don't want to that's really high as we want to measure. So, here it's saying that resonance of a single tone from 44 to 31 is typically around 250 millimeters. 2 tones brings the resistance below 90. Third grade or 60. And so to get a resistance, high resistance, we need to explore tones or 40. So that's why I think it's different choose 43 the 60 millimeter. So that you get more tones, you get a higher resistance, fewer forwards, and try to make this as lightweight compact as possible. So, in the same document, there's some hopeful graphs here that talks about for type 61 VHF. 2 tones gets us pretty close to our 2 frequency and roughly 1,000 amps. And this is probably going to vary resistance here, depending on what it is. So, let's get right to it. Definitely read that document. Let's DNA set. Alright, so if you have a nano DNA and never hooked it up to your computer, this is what you need. Go to nanodna.com website, and if you scroll down into the download section, hit download, and it's going to bring you to their GitHub page. And all you have to do is click this, and you'll download the zip file, and the deploy it now to open. Alright, so the zip file that you downloaded, just open it and load the program that's in that file, file. And this is a note here, anyone with Windows machine getting this program, installing this essentially, using it might be different with your Linux setup. So just using your Windows here. And so at this point, this program will go ahead and connect to your DVD to your computer with the USB cable. And it has to be a good USB cable. I've tried with those cheap USB-C cables and all that stuff to charge. Those don't work. It has to be like a good one. Maybe the one that you use to charge it or something. So if you don't see a port here, where you can talk to your rescan, if you still don't see it here, it's possibly that you don't have a high quality USB cable. And for when you need to restart your computer or run the program or try to restart things. Here we have our DVD. You can just click connect to the device. And now we're connected. So we still have to calibrate this, but let's go to the red port. So just calibrate and let's get to that. Alright, so what I have here is a little breadboard, and I have two little circuits, and all these are resistors to bring a 50 ohm power resistance. I do not have a 50 ohm resistance, so I'm just using 2 to get the power. So both of these are the same. So you're going to want a little breadboard or something similar to 2 circuits, 50 ohm resistance. Secondly, you'll want to create some little cables like this that you can hook to the main of the unit. So this is SMA, and one for ground, and one for the center pin. So you can hook up to the wire as well. So, starting up 2 seconds. So get down to here. And also what's helpful is I have a little diode. And it just makes it a little bit easier so I can connect one end to coax using this other end. So it's connected instead of one. If you don't have a nice little choke dummy like this, you could put some wire and use a 50 ohm default valve to turn it. So there's a way. Alright, so let's the YAVAPI side start. So alright, so we have a YAVAPI connected. We have a breadboard, 50 ohm resistors, and all the clips and stuff. So we're ready now to start calibrating. But before we do that, up here under speed control, set your start and your stop frequency. And segments, I like to just do 10, and that gives us a little bit, we'll start seeing better and better. Markers, we can play around with it later. You want to get this set first, and once that's done, you can go down here to calibration, come out, and use calibration assistance. And what it'll tell us to do is, if we're ready to proceed, just click OK. Alright, so now it wants us to connect the short strings to port 0 and everything down here. So let's go there. Alright, so we got a new idea. We have our little jump coax cables. Alligator clip leads, put them in. So these are all on. And in case there's any confusion, for channel 0, it's the red and green line, channel 1, white and red. That's all about the channels this thing. So, for channel 0, we want to show the wire. So, we just put these alligator clips together, and that's it. Alright, so we have our channel 0 alligator clips, the green and yellow line put together, so we're ready to click OK. are open, experiments open, make sure they're separate. That's that. Alright, so now it's channel 0 alligator clips, the green and yellow are disconnected and not touching each other, so I'm going to click OK. Awesome. Just see the progress right here. Doesn't take too long. Alright, so now it wants us to connect to the load. So let's go do that. Alright, so now we're going to connect the channel 0 to load. And all we have to do is take one line, one into the surface, and one line to the other end. Make sure you got a good connection. There we go. So 50 amps. Alright, so now our channel 0, green, and yellow wires are connected to a 50 ohm load. So click OK. Sweet. Alright, so the required steps for one port calibration are complete. You want two ports. So if you wish to continue with two port calibration, press yes. Alright, so now we want it to load channel 1 basically as well as channel 0. So let's do that. Alright, so we have our channel 0 already connected to the load. So now we need to snake our wire around for our channel 1 and get this connected to the surface. And it's on there. There's channel 0. Make sure the good connections. Okay. So click on and also click on. Alright, so now we have channel 0 and channel 1 connected to 50 ohms. So click OK.
That jammer sure sounds like Billy Quilly transmitter from Diamond Springs. So what happened to Greg?
Alright, so now we're about to do the through.
For a signal comparison now between
Alright, so now for the through calibration, we connect all these from 50 ohm load. Weird guy out of here. And what we want to do is connect some green wires together, so ground to ground, and the center wires are connected. Alright, so now we have our two green wires connected for the ground, two central wires right now connected together. Click OK. And all we're recommending doing is calibration every time you change or start or stop, and possibly yourselves, yes. This is it. That was a pretty quick calibration. So we're all done. So all calibrated. Alright, so now that the calibration is done, you can close the calibration assistance. We changed the display a little bit. We're going to want to measure SWR. The gain, typically we want to get it negative 20 to negative 30 or better for noise suppression. And then S21 series for measuring the resistance. And so to get these windows up, you can just go to display settings, and under display settings, you just use these drop downs. So you just select pick it and it'll pop up. So that's how you get to do it. And then when you're all done, you just exit out. So let's start building our chip. Okay, so now I'm about to station the RG316 caps, and what I ordered at Amazon, you can just connect it there, and another character, which will just cut off. And script installation, so it's called out of field, and center, and go for exposed, so So get 3 feet of that.
And the date code
Here
is
you want to go. It zip ties, and these are the tour roads. So if you want to follow along with this top of the mountain down here, it's in these. I recommend if you decide you want to experience triathlon, I recommend doing the feed style, the real big. That's because when you drop the coax, get really whole picture of the water without having algae, even without putting on subtitles. It's impossible to wrap it around as well. So I want to measurements first.
You got a great signal here, 15 to 20 over on the
So,
peak. I don't know what happened to Dana
what
anyway.
you want to do first is
Well, he's chicken shit, whatever.
measure 21 inches from whatever style step you start at half. So 21 from here to the beginning of the first foot. Okay, so I got a mark on my wall, roughly 21 inches from the connector. And so what we'll do is we'll take a photo and pass it through the center. And every time this coax goes through the center of this forward, that counts as 1 pen. So this is roughly a spot. And then we're going to take and do 1 more pass through for a total of 2 pens. And you want to be careful with how you wrap these things. We have 2 more other forwards that we're going to they all have to be in the same wrapping sequence. So for example, this one you can see that the new wrapping is on the bottom here. But the other 4 are the same actually at the same time. You don't want it to one like that or else the wraps will be too
But it's doing an investigation.
keep the wrap on that same orientation. And what we want to do is get a roughly 1 inch under the thumb. And we can always experiment with bigger loops. Don't go too tight there because you don't want to ruin the coax. So I go about 1 inch. And now's a good time to re-measure. That will have a forward about 21 inches. That's pretty good. And then take another forward.
The capsters are my favorite. You know, the 30 megahertz delay follows the 30 hertz
Pretty close to one.
You know, it's all good, over.
Pass the coax through the time.
You're like the CSR
And then I like to kind of have them overlap a little bit. So it's kind of like that. We'll try to get the loop about the same size. And you see how it's the looping sequence is roughly the same. It starts at the top, and then at the bottom, and then at the top, and at the bottom. So we're not casting our turns. And then we'll just take our third forward. And do the same thing. Go in one, and then down, and then
A little bit of scratch is okay, you know. You get some beans and rice, you know, and chop up an onion. For vitamin A.
Just like that. What we're going to do is measure and see how this works. Pretty close. Then we'll start wrapping zip ties.
Right now that are out there.
And also before we secure stuff, you want to see do we have enough coax there to go from the center of our mountain to it's like a 20. So definitely have better to have a
It's a
Alright, so we have a quick test from the Nano DNA. We're going to do is connect the 2 round wires, 3 miles away. And on one side of the coax, we're going to short the ground wire and the center wire. just listen up there, decent caption, and you can actually be a yellow or white one. And then the remainder sample you want to short these out. It's all in the field. What I do know on CHINO, let's take a short piece of wire. Try to pick on that. It's not like that. Alligator pick and that. And short. So now we're all set. So we can actually computer and get all of them. Alright, so after you have your choke pushed up to 1 minute, and you just hit this sweet button here and let it progress to 100% and left to right results. So, looking here at the S21 game, you can see here that we're running under negative 20 dBA, which is pretty good. You don't want to get negative 20 too low. And the camera out there on the sailboat, you can suck my resistance with this yellow line, and you can see this, all three markers that I have are above 500 ohms, so that's and then add markers, you can go down here into the frequencies, and then you still have to so it's called waveforms.
And he used to do like shows on stage, just chewing his pig, but it's a pig.
You can ignore the stable
and in the afternoon we had
so
that's the secret
right here, you play with your loops, play with the spacings, and see if you can get pretty decent values. A little disclaimer, I have ran this before making all sorts of results. So it's me targeting USB is as far away as I could from the computer. Manually pretty far before I can get to there. And recalibrating these things because it takes a lot of computer and gymnastics to make clear all the space, rearrange stuff. And also, these alligator pick wires, if they were a little bit shorter, like the wire that they were, it works. Just keep that in mind if you start seeing some things like that. So now let's go take a look at the next step here with tightening the loops. Give it a going on. So on my loop, pretty close to I would recommend exactly what they want to measure the test of this. I know for since I was running these jobs, you know, mix of magnetic loop. I know most of those things. So I know here that's where they are. All these bastards are. If you're different mix of photo, I'm going to go ahead and zip code. What I'm going to do is start filling this spot, and we're going to take the tail, so there's no get rid of that highlight. Because I noticed in last filter in there, I left all those highlights that show measure the light. And then when I click it, it'll settle that. So I think there makes sense. You just need to zip tie, measure, make sure it's good, it's going to fill with the thickness. Make this need to be a little bit tighter, and this is a really good spot, so I'm going to zip tie this side. And then measure again, and then zip tie here, and then so just to go over real quick the zip tie process. Started the zip tie this, measured, and the zip tie here, measured, and this zip tie measured, and then this one. just to do a little bit more of a close-up. What we're trying to do is keep these roots from being able to shrink or expand. And so just trying to really pull together. So I only have 1, 2, 3, 4 more. Alright, so there's our coat all done. One thing to keep in mind when you're cutting these, make sure this wire, the root, on the back side. This is the last time on this ring is out. Holy crow. So there's kind of sequence. And then you can always overlap these, so make them feel better against the tail like that. And then when they test it, see which follows. Alright, so here are the results of our finished shape. So you can see here, it's under -20 dBi, so that's the noise suppressant, so that'll help. And then here our resistance, and that's probably at the upper end of the band, about 900 ohms. We're 1,000 here, the lower end of the band, so that's pretty good. So now the next step is we need to measure the SWR, so let's go to the generator to see what that says. Alright, so for measuring SWR, we're not going to be using the channel 1, so we can take that off, pull off the sides, and we just got channel 0. So I'll see what we get this out of. So now we just have our two tables, and on the coax connector side, I just put in our dummy. If you didn't have a dummy ready, then you can just make some equipment there. Obviously, if you want to be looking at circuit here, and then the center point to the and then I am the wires here, we have wrapped around on the last end and separate the outer wire, and the center wire, and then all the far back and beautiful sitting over here center pin, and then also the center pin, and then you're good to go to test. I have run into some problems. I'm not testing it since I haven't used different 50 ohm load source than the one I followed. I have made this last year get through all the possibilities. So what I'm going to do is I'm going to compare it to recalibrate and use this dummy load and 50 ohm load source recalibrate, and I'm going to skip the last two calibrations that so the power the finish is more important. If you are using the same 50 ohm loads and then just getting the calibration that we just did, proper load source. Not sure you might do it slightly off turn fail, but you need to pass it as so I recalibrated and now hooked up my pelt connector to SWR. This might be a good test for you as well. You can get this week and recalibrate if it still hooks up to that 50 ohm load source and just confirm you're seeing a 1-to-1 SWR. And that will kind of indicate whether your calibration is good for your test results. So I just did a SWR sweep. The value of the band in general is 114, and SWR for the band is 120. So it shows resonant, a good SWR, good resistance. So the next part is we need to put size. So let's go to it again. So now that we have our short grid, we're going to need to add coils to the grid. And before we do that, this rectangular slot is how I secure the choke. So I try it, and sometimes I just kind of bring it out like that. And you can see we got a lot. So that's what we're gonna do. And we can always cut too short. We can always bring it out a little bit further. So I think I'm gonna cut off a little bit there, and then we can add a thumbnail. So I got some coax prints, and I was doing pieces with the Velcro. I can attach it. We got good so we're ready to put some thumbnails on. Alright, so I'm gonna take our choke that we just built, make sure it's round, all the sheath wires, there's no loose wires on it, I can hit the center connector, just kind of that, and now I can take a small piece of heat shrink and slip it over the ends here, and what we're doing is this, after I get everything, we're just going to heat shrink it kind of down there so it'll keep water off and then we're going to want 2 little pieces of heat shrink so we can insulate these ends. But what I'm going to do first is I'm going to fill this up with solid. Once it's all filled up with solid, we'll heat it up, and then we'll put our heat shrink on like so. Heat it up again, and just basically put a wire down there, and California, we've got Greg K7, and then same thing for the other side, so we fill up the side, and we have UK, and then so now this filled up the side, and what I'll do is I'm just going to put the sheet shrink here, and we'll heat this up, and quickly try to put that on there without this melting and shrinking being able to put on. So let's give it a try. So here, once it starts to melt,
okay, what's the name there?
the wire starts. There we go.
Very fine shade. Nice to make your
Same for the other side. I'm already got me stuck in place. So we're ready for the solid. I went ahead and cleaned this outer sheath wire so you can see heat shrink on. Beat this out. Alright, so now I have the aluminum with both arms. Not the prettiest. Got some heat shrinking on there. Help with insulating. You could always print these if you want. I decided to try to make it more waterproof. So the next thing is we're just going to slide this up and just heat shrink it out in place. So there we have it, end of our feed point. So go ahead and get your antenna and a piece of Velcro like so. And in the center part of the beam, there's a sort of this kind of slot that feeds the Velcro through that. And then right through. And this Velcro will stay the same. You won't have to keep taking it off. Because it'll help winding the wire and security too. So for this purpose now, I'm going to take the choke and with our terminals, we're going to put the Velcro through the first one. If you left your tail here a little bit too short, you can go for the second or third one, or rearrange how this first loop maybe secures it out on whatever works for you. And just secure in place like so. And then we'll take our point, loosen 0 and X. Take the other end of our ribbon element, secure it in place,
and then one up here, we call them,
and it doesn't matter whether the center wires on one side or the wires on the other side. Just secure one at a time. Get started.
Yeah, I can hear you.
The other side.
Yeah, he's a real prick.
Alright, so then you just cinch that down tight. Some loose connections. And now we're all set to go take it outside and do some measurements. Alright, so you're going to put this on a non-metallic mass, away from all metal objects, so you can see the network's readings. And to hold it up on that mass, and we're going to use silicone bands, just like that we have it here for these spreading units. And it just attaches to the nails. And if the rubber band is too big, you can just wrap it around so it's not as tight. But I'm just going to lay it on the top there, hold it in place. And then on the wire spreaders here, where we have our heat shrink, I'll just put this on just like if we were to heat shrink it on there, just in case there's any effect of our wheels. So just put that loose on there and make sure that all of this is straight. Feed point on there, the Velcro, and it's just going down right here, right behind it. I don't think it matters. And then I'm using the 8 feet of coax that goes to the nails.
He'll pick it up. Popcorn. Some good cattle corn so I can enjoy.
So now that I have that design, I recommend before we heat shrink it, take the wire off the fender just so it's not tight. Because when we heat this heat shrinkers over this wire spreader, this wire spreader is going to get really soft. And now you don't want to have that tension where it's going to stretch it because this space is right where you want it. So remove the tension, and I'm going to put this on there, heat it carefully just enough so you need it, and then this may want to try to curl on it. So when it's cooling down, try to keep it flat. You might want to put your hands on it, move it, just push down on the flat surface. So we're going to get these heat shrinks. So we're going to put heat shrinks nice and tight, our spreaders are straight. As it was cooling down, we just try to hold this on, make sure it's all straight. And that's it. So the next thing, which is an optional step, is you can use some thread washer. I'm just using this blue conductor. And just back out these screws and apply a tiny bit. Just, I know it takes a little bit. I don't know what this would do if we got on the plastic, so don't do it. Just completely optional. And the only reason I'm using this is because over time I've noticed these screws come back out, and I have to get screwdrivers to tighten them again. So I'm trying to just thread loss it. Looking at small tiny. So I highly recommend it. Alright, well that's a wrap. I have about 4 of these maxis now. All 4 of them, the measurements have been pretty consistent. Very small differences between all 4 of them. But if you follow these instructions, you should have pretty similar results as what I've gotten. You can always play around with these wire spacing. So how we have to put some wires forward and move it a little bit. You can try to increase it. You can try to put a little bit less in there. You can try to the tail end pull it back and see what that does. Pull it straight forward to increase the spacing between the 2 wires. So you can try to play around with that, see if it gives you better results. But anytime you do changing how much wire you can carry or less, you want to measure from that corner to your wire spaces if you're distributing on both sides to make sure that the spacing is the same on both sides. But other than that, if you follow instructions, you should be pretty good. I hope this is a fun day for you, and I hope you get a lot of use out of this. It's been a great time for me so far, so I hope you enjoy it. Anyway, I'll catch you in the next video.
Yeah, very good. Well, the jammers, they come and go. There's a time of day. Somebody that actually wants to get in here.
Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today we're going to take a look at a 1940s Forestry Service radio transmitter and receiver pair. So the 2 separate units in one case. The case is very, very heavy with that. It's iron inside. So today I'm going to give you what electronics works on radio anyway. I'll explain exactly how both the transmitter and the receiver work, and what it's going to take to convert this into a ham radio. So this should be a lot of fun. Let's get started. Here is the transmitter receiver pair all in one case, a very, very heavy case. I'll show you the back side of the case here once I get these out, just because this is very heavy to move around on the bench. So because this is a transmitter and this is the receiver, the transmitter is mounted on the top for a reason, even though this is the heavier piece. So most of the iron will be on this piece right here. So it's standard transmitter stuff. We have an antenna binding post right here, no coax, because that's just too expensive. We have a plate current meter right here, and you would tune this for a dip. So when you find the dip, that will be the point of maximum output, or close to maximum output. A lot of the times the maximum output is just outside the dip. But I'll get into explaining that later when we get into tuning amplifiers. So it would make sense for a new operator to think tuning this for a maximum on the meter would be maximum output. Well, it's actually the opposite way. You tune this for the lowest point on the meter here, and that's when the output section in here is happy and it's working perfectly. Alright, so if you tune this for maximum, your output power is going to be lower, and the output tube itself is going to draw excessive current and burn up your output tube. So one of the radios in ham radio history, I think that was probably the hardest on output tubes, just due to operators not understanding how the output section works, is the YAVAPI FT101. I think output tubes feared that radio. I have pulled output tubes out of YAVAPI FT101s that are completely melted. The glass is melted on the tubes. That's how bad and how hot those tubes are. Just because people were thinking, because they weren't using an output meter, that they would tune it, and for a maximum on the meter, they would just melt those tubes. I know I have one somewhere. If I can find it, I'll look for it through this video, and I'll see if I can find it, and I'll leave you an example of one of those. It's one of them was really bad at the same. Anyways, back to this thing. So we have a neon bulb here. Its purpose might be just to indicate that the transmit section is on, or we might actually have been using this as an output out here. I really don't know. It's got a nice shiny spot on it. Looks like it's in hard use. So transmit receive switch, microphone input most likely, I'm imagining. This controller here is supposed to stay where you put it, but it's so well used that it won't stay in the dip. So it's, if you were to use this in this condition, you would actually have to hold this in the spot where the dip is while you're talking on the microphone, or just, you can see smoothing up its way. So it's pretty bad. So it's well used. On the bottom we have a receiver, and it looks like just a single band, and a beat oscillator on the bottom here, you can see that, and let's see, can you see it? You might be able to see that. Beat oscillator RF gain control here. So the beat oscillator would be for, I guess you could say, zero beating the transmitter into the receiver. So what would happen is you would tune this thing, and you'd have a tone on this, and you would tune this to the same frequency so that you can have them synchronized. Let's put it that way. They're not locked together. They're two completely separate units in one case. So we have a tone control, on off, and volume control. Very simple. This here, it looks like a here. Maybe that stands for cameras. And let's see what else we have here. Y. And anyways, that's about it. So this looks like a portion that you can buy. This looks very national. I'm thinking that probably is national. And yeah, so this is, I'll see if I can find this. I think this is part of a kit that you, or not a kit, but the pieces that you could buy to assemble this. Now this, oddly enough, this doesn't look like this was assembled by a company. It looks like maybe somebody was asked, maybe a ham operator back in the 40s was asked to put something like this together. Or maybe this was a very small run and a small company bought parts and pieces and put these things together, because this looks like parts and pieces. Again, this looks very national. And we have the chicken head knobs. This would be very easy to restore. just because you could remove all the nameplates, take out all the screws and everything on this would come apart, you'd have just a clean faceplate, and it would be the same with this. There's nothing written on the faceplate at all. You can take this apart and respray this, and you would have a brand new looking transmitter, which I will do in the future. I'll take this thing completely apart and turn this thing into a single band transmitter and receiver pair. So those would be both of them will get restored in the case itself. Remove the hinge and the pieces here and everything like that. So it'll be a really neat little project. We'll bring everyone along through that process as well. So getting this thing apart doesn't look too incredibly hard. On the back there is no screws. So again, I would turn this around and show you the back side. But this thing is, let's see if I can give you an example here. It's just that whole bench is very, very heavy piece. So, and then the transmitter is on the top. So, problem with these screws and sliders, screws here on the top is that they slip the thread around and score things. Yes, very, very heavy. Okay. And you can see why it's so heavy. Look at all this iron. This big transformer back here, another one here, another one here, another one here. So this is the transmitter right here. And it does have some wiring in the back. You can see that here. So what I'm going to do is back on here for a moment. So what I'll do is I'll just pull the plug out of the back and get some of the wiring out of the way. I'll move this case out of the way, and we'll take a look at the transmitter, and then we'll look at the receiver. Here's a quick look at the case with the transmitter out. So you can see it slides into this area here quite nicely. And on the back side, it's just a grill for venting purpose, I guess you could say. And the bottom's like a cord storing up. You might be saying, well, how do you ever send this from the forestry service? Well, I'll zoom on into this little tag here. There you have it. That's what it is. So British Columbia Forestry Service radio service tag. So the last time this was serviced looks to be in 1972. So I don't know what that says there. Something 27 or 72 possibly. So, and it's serviced by somebody's scribble right there. And we'll take a look at how well this was serviced in just a minute. So it sees me the serviceman did his job well done. Here's a look at the top side of the chassis, and what I can tell you from just looking at the top side is we have a power supply here and audio section, and this would be the RF section on the other side. Now, how I know this, it's very simple to recognize. You can see that there's a crystal here, so this thing is locked down. It's stuck on 3315, so way back when this would have been in the HF area, and it would be 3.315 megahertz or 3315 kilohertz. So things have massively changed since way back when. The police used to be just above the AM broadcast band, right? And nowadays everything's digital, and cell phones and everything like that. I would imagine, I don't know this, but I would imagine that the modern forestry service frequencies are probably around the HF, just like those that use their cell phones. So this is old stuff. So 3350 would have been the frequency that this transmitter was fixed on, and who knows, maybe this even got into some other company's hands, and this is their frequency. I don't know the history of this thing, other than what was on that tag, right? So this is a nice looking crystal here. Let's see that just plugs into here. And this would be here to trim the crystal, or make it happy and oscillate nice. We have the oscillator here, 6V6 crystal oscillator, nice 6V6M. This looks relatively fresh actually. See that there, 6V6. And then we have a 6L6, which would be the RF output tube in the case circuit right here. So crystal oscillator, output tube, and then basically send this into this right here through a transmit and receive switch. We have a bunch of adjustments. This is most likely to tune this to this, and this is most likely to make this crystal happy, so make sure it oscillates on the correct frequency, turn it up. We have another adjustment here, which I have no idea what this is for. It could be bias, who knows. So we'll have to find that out when we look at the bottom portion of the chassis. Filter capacitor here, which is put in a very sloppy manner. So I'll show you that here. See this? Someone's replaced this and they just tightened it off to the side. So there should be a washer under here and a washer on the top, so this could come loose. And let's see if look at that. Some radio service when is I guess just trying to get them back into service pretty quickly. So don't vibrate or move the transmitter too much. So anyways, should have been handled in a different manner. We have the power transformer here. Most likely a filter reactor of some sort. This looks like an audio driving transformer for this section, so from audio to the output, possibly high-level modulation, so possibly plate modulated. I'm not quite sure at this point, but we'll have to find out. This looks like an audio interstage transformer of some sort, so maybe from the microphone to the input of the 6C5. So 6C5 would be the audio driver tube down here, and this tube is going to drive the audio output tube, which is most likely going to be in Class A. So another 6L6M. Now, most guitar amplifier owners know what a 6L6 is. 6L6 is very common too, but there's quite a difference between the 6L6 and the 6L6GC. So this is the 6L6 version. So the 6L6M and the 6L6G are very similar, except one's in a metal package and one's in a glass package. The 6L6GC, it has better plate dissipation ranges. So most of the modern amplifiers that you find will have the GC version. A lot of people say, hey, I found a really cool old set of ST-style 6L6s. ST stands for shoulder shape, which means that they have the Coke bottle kind of look to them, is how they're known. So it's not safe to plug those into a modern amplifier. It's okay to put a 6L6GC in this because it has the better dissipation range. You can't go the other way around. So if you have a modern guitar amplifier, do not plug old 6L6s in. So 6L6G, 6L6G, 6L6M, you don't want to plug those into a 6L6GC system. Okay, keep that in mind when you're just destroying the tubes. We have a rectifier here, which looks like somebody has made a solid state replacement. Why would they have done that? Well, you get a little bit more power output out of the transmitter section, a little bit less heat, and solid state rectifier diodes have less drop. So vacuum tubes have quite a bit of drop across them, so they use a little bit of power running a vacuum tube. And in a case like this, if I were to show this, I wouldn't care about that. Now this socket looks something like an E or maybe a 5Z or something like that. This is the old 4-pin style. So in 80, the number 80 to power up this whole transmitter would have been a pretty bad choice back in the day. And the design of something like this, or maybe a 5Z3 would have been a better idea, but I really don't know what they've put in here, so come time to restore this whole thing, probably fit a proper vacuum tube in just to keep this back intact. This is most likely maybe a gain control or bias settings. As I said, don't know it because I haven't looked at the bottom side. Antenna binding post right here, which is very loose, wouldn't be very good, so it needs to all be tightened up. What else can I tell you? Meter, and on the top side, that's pretty much it. So let's take a look at what they've done on the bottom side. So very easy to recognize quickly is whenever you see the crystal, you can pretty much see that this is in line here. So this would be the RF section, and then we'll have the audio section. So this is the audio modulator section right here. And they're using the transformer as shielding between the two, because these are all clamped to the chassis, so it's creating separation. They've also used metal type tubes, which the outer portion of the tube with pin number 1 of the vacuum tube is grounded. It means that the shield is connected to the chassis, so you get lots of nice shielding on the upper side of the chassis. So they did a good job in component placement on the top side here, and by using tubes. I prefer glass just because it looks nicer, but when it's in the case, you don't really see it anyways. So let's take a look at the bottom side. Well, now we know why the repairman's name was just a scribble on the tag. Look at this repairman work here. So we have a line cord here that's been taped up as well. And then the line cord runs into this black tape right here. One side of the line cord on this side, other side on this side. And this messing it out. A filter capacitor taped onto the power transformer leads. And these look okay. These look like the transformer is baked. Where those leads are tight onto the chassis right here. Looks like they're almost cutting the wires. So this was tacked into circuit. And we can see this one's tacked in the same way, so these were most likely changed at the same time by the same serviceman. Now you might be saying to yourself, what if this thing was repaired just quickly because of an emergency or something like that, and was never looked at again? Well, we see on the repairman's tag it says 1972, and these capacitors are built well before 1972, so this was done well before that and was never fixed properly. So the serviceman was me to talking to was that fella's boss, and I saw this thing, and oh boy, what he had, that's just some bad work. Now he was tacked in the circuit properly. So anyways, right here we have the some leads of the audio transformer which are just taped off. So whether the audio transformer has failed over time, they patched this up and basically changed its modulation scheme from a high-level plate-modulated circuit to maybe some form of reactor-type modulation and pinch, something like the Heisen setup. That will have to be discovered at the time of power up. We'll see what happens when we're able to draw this out. So let's start here with the RF section first. So first of all, this adjustment here is not across the crystal, it's actually tuning the coil on the plate of the 6v6. So this crystal itself, as you plug it in, and where it is where it is. You tune the plate circuit of the 6v6, and then this adjustment here between the 6v6 and the 6L6 is the drive level. So this is the amount of coupling between the oscillators and the output tube right here. And as you can see, the plates of this capacitor are almost fully meshed, which means that you've got maximum drive. So we're looking for maximum output of this thing. You can see what they're doing right? This capacitor here is a neutralizing capacitor. Why is it called a neutralizing capacitor? Well, it stops the amplifier, or the output section here, in this case, from becoming its own oscillator. So we don't want this to turn into a VFO. We want this just to tune the circuit, not to tune frequencies. So this thing, without this capacitor, would have the ability to parasitic oscillate or transmit on multiple frequencies at the same time. You don't want that to happen. You don't want this to turn into a VFO. All we want to do with this is dip the plate. So without this control right here, what would end up happening is this thing, in some portion of the tuning, by moving this thing around, we might find that it'll break into its own oscillation and start transmitting on two frequencies, and then all of a sudden just stop when we get to this point. And then all of a sudden it pops into oscillation as I'm moving this and then stops. So this neutralizes that effect. So it's a neutralizing capacitor right there. From the output section running back to a previous state is all that that does. So for the first tune-up on this, so you have this binding post on the front attached to the antenna. For the very first tune-up, what you would have to do is tune the antenna with this thing slid out of the case a little bit, and then of course we'd be looking for a dip right here. Once we have the antenna tuned and everything, this could be slid back into the case, and then only every now and then you have to check to make sure that the final circuit or the tank circuit is dipped. Okay? So we want to make sure that we've dipped the plate of the output, let's put it that way, with this control every now and then. Now you can see that they've been looking for a dip a lot because it's looking for its own dip right now. So this is a very, very loose. So this has been used a lot. So chances are there is some problem in the output section, and we're continually looking for that dip. Let's see what else. So this runs off to the switch, which is the telecom or telephone type switch over here. And basically this switches between receive and transmit, so switching multiple things in here. So most likely switching some voltages, and of course it's going to be switching. Right here, this is going to be switching from receive to transmit. So the receive, the signal from this binding post on the front in the receive will come through here and go into the receiver. And then when you click this into transmit mode, what would happen is it would cut this off. It usually would short this, and then we just have the transmitter running out of here. So that's what this switch would do. So this would be the receiver code. This is another plug that comes out of the back of this, most likely either a speaker mute, or this is going to cut the B plus in the receiver. The reason that they have this is when you click this into transmit mode, you need to mute the receiver. Well, what will happen is when you're talking in the microphone, the mic will hear the speaker of the receiver and you get feedback. So you have to mute the receiver, and that's what this is going to be for. There's multiple different ways of doing that. Some ways are better than others. Cutting the B plus in receivers is not always a good idea because you get drift. So a lot of the times just muting the speaker is the best way of doing it. Unfortunately, most of the common ways way back when was to actually cut the B plus. So you get receiver drift by doing that. So we'll see what they're doing when you look at the receiver drift. So that's a quick overview of this. When it comes time to actually rebuild this and test this, what I'll do is I'll probably get a VFO and attach it to the crystal area right here, and I'll tune this into a ham radio, amateur radio band, where it is legal to transmit on this thing, and we'll tune this thing up in the AM phone section and see if this thing makes any power and maybe if it modulates. So we'll do that before we rebuild this whole thing, so it should be a lot of fun. It'll have to be brought up slow and bariac. Hopefully the filter capacitor are still working and everything like that. And we'll see what they've done. Audio transformer. So the chain of events in the audio section, just before we go to the receiver, is from the microphone and the jack in the front here. It goes through this transformer into the 6C5. The 6C5 would then amplify that signal. The signal will be at the plate of the 6C5. The signal will go through the capacitor into the 6L6, which would be in class A. And then that would drive this transformer, which the transformer would then modulate the RF output to here. Now, again, they may have changed the scheme. It might be some form of reactor modulation or Heisen modulation, or it might actually still be plate modulated and you just tap some leads off what's going on. Nice looking receiver. Cute. So we have the removable little tags on here. The only thing you can see if I was trying to paint this, it would be an issue is this here, but it looks like I just added this and smeared something on top to stop it from being rubbed off with a finger. I think that this can comfortably be removed. It looks like somebody's scratched a J and a G in here, but it might just be done with a pencil or something like that, so it might be able to be removed. I think that's just done with a pencil. There's some writing on the dial behind here. There's a power down here and K up here. So something can probably be done with a scan this and get rid of all that dial for here. So 1.5 amp fuse, very straightforward. With a pilot light on the front here, jewel light. So inside, it's very well put together. I mean, this looks like this has been stamped out and they've made a bunch of these things, just the way that this is done. So, turn out just a touch so you can see all of this. So the chain of events, we have a rectifier here. It says 80 here, so I imagine there's probably the rectifier tube in the frame, there's probably a as well. Somebody's taken a 3D28 socket and shoved some diodes in there and made a solid state rectifier. The 80 would be fine in here. We're giving an advantage to this but for the transmitter section, if it is easy to use, the diodes would really benefit of that for sure. A 6K6 obviously is the audio output tube, so this drives the audio output transformer, drives the speakers. 6K7 off the front end of this capacitor, which is going to be the front end of this radio receiver most likely. So the signal will come in this little jack on the back. Most likely make it up into this area into one of these coils and go into this as an RF amplifier tube. And most likely through here into the converter or mixer oscillator. From this, would most likely go over to the IF chain over here, so basically right here and here. And the this would be the amplifier. 6SQ7 would be the detector and audio. And let's see what this is. 6SQ7. So we'll go from here into this tube and go up to here. This would be the VFO over here, most likely. 6SQ7 common tube for VFO use. So the chain of events is in this tube, from here, into here, from here, through here, into here, from here, through the IF chain, it's detected, and then from there into the open tube and into the speakers. And of course, just VFO use for 0 to 0.1 dB. So, pretty straightforward design. Nothing too special there. It's like a bottom side. Lights. Those sound capacitors. Whoa. It's starting to yeah, so there's some capacitors for this thing. Lots of that. So all of those have to go, and filters have to go, and here. Other than that, looks like a pretty straightforward design. They leak a lot of the time, but there's a good chance that this thing still work. I'm going to find out here. And I had some power and just a minute to try and because that's it. So this is the input here. It goes from here into here. Yeah, it's looking like the chain of events. So this is the antenna coil. Alright, so it goes into here. Here. And this coil here. From there. So this has got a green cap on it. Yes. Yeah, so it runs into here and then into this. So this is the first RF amp. Yeah, it's just as like this is actually this is this is most likely going to tune the plate of this tube. This will probably be loss of the plate. And loss of the adjustment trim down here. Very simple. So it should be a breeze to rebuild this thing and move it into the meter phone band. So this should be around 3 point, what was that, crystal 4.45 this? So, hey, let's give this thing some power. Plug this thing into the isolation transformer. This on. Alright, this would plug into the transmitter batteries, so the transmitter there we go. Basically, it's down here. So let that sit for a little bit. So what I'm going to do is I'm just going to leave this like this, and I want the capacitors to reform for a little bit. So I'll be back in about 15 minutes or so, and we'll see if anything's happening. So far, the bulbs are doing okay, so I'm probably going to move it. See that up on the top. Again, I'll be back in about 15 minutes. I just look at the stops slowly reform. About 15 minutes has gone past, and the bulbs are still nice and dim, so that is a good sign. So if you recall, this thing had a needle on the bottom of it. So that would be the two larger pins here. One of the pins is grounded, so it's either grounding the cathode or the coil or grounding the speaker or whatever. When the time comes to go through this thing, it's probably the cathode or the circuits or something like that. So let's see what they're doing. So on the side, it's one up, and this is the magnet coming up just a little bit. Let's see what happens. Came to light, it's humming. Hear that? That's for one now. So So that's the antenna jack. See what happens when I touch it? See, it's trying to receive any sort of parts. Alright, so I have my 369 antenna over here, and I'll make sure it's switched. It is on. Okay. Let's see what happens. I'll turn the volume way down because when I attach this, it's probably going to be pretty low. Well, it's good. I did turn it down. It's wow. It's pretty loud even at that. It's trying to receive. So let's set this over here a little bit so you can see what I'm doing. A little movement. This here. Okay, so the dial. I was trying to receive, there's just nothing on the band. Tuning capacitor's got needs to be cleaned. For a second, maybe you had a high voltage short or something like that. It's not uncommon, you know, you bring these things up and the capacitors go up, so it's alive. So while it is alive, let's see. So the crystal frequency in the transmitter is 3.315. So what we do is I will turn on my signal generator. There is some attenuation in these blocks. Okay, so we have, yes, find it. Alright, so it's 600 cycles, 50% modulated at the crystal frequency, so you should be able to find that on this dial. So, because the transmitter receiver should be there. There it is. And it's right at the letter K. So, there we have it. Not bad. So I'll remove the antenna connection here. And I'll just show you. It's right. So I don't know if I can move this around and show you this at the same time. Plastic dirt on this is it's so incredibly hard I can hardly pinch that open. So let's move this around here so we can demonstrate this. Is that okay? So it's actually doing pretty good. You know, there's attenuation in this box as well. So it's, yeah, so the tone control works. It does. Gain works. So that's at 50 microvolts, and again, there is attenuation in there. So the thing is receiving really well, and still it's at reduced line voltage because it's through the bulbs. So let's bypass the dim bulbs. Here we go. It's really coming to life now. So that's at full line voltage. So let's see what happens is take it down to 10 microvolts. Still there. And through the attenuation, it's actually a hot little receiver. Nothing's been done to it. So this should very easily convert into the 75-80 meter phone band. So just by moving my coils around here a little bit and a bit of tuning, I think this would make a really nice transmitter and receiver pair. So there we have it. Let's see if the VFO is going to work. Let's see if that, I can barely hear it in there. I hope you can hear that. See if I move this around a little bit. It was working. It made a bit of noise and then it stopped.
We're not all the same. We're all off in different directions and, you know.
Yes, the BFO definitely needs a lot. It's nothing. The receiver is working the way it is, so not bad. So it looks like it may have been serviced through time a little bit. The cap on the corner here is missing, and they put some of these smaller under chassis capacitors in here, but other than that, it looks pretty much original, and it's working like this, and it's very sensitive as well. So it should be a lot of fun. So, in the future, we'll definitely put a transmitter-receiver pair together and maybe make some contacts in the 80-meter or 75-meter phone number. Thanks for stopping by the lab today. Hope you enjoyed this video regarding this 1940s forestry radio. If you are enjoying our videos, you can let me know by giving it a big thumbs up and hang around. There will be many more videos like this coming in the near future. There will be lots of solid-state electronic repairs, designs, and rebuilds, and a lot of antique electronic repairs, designs, and rebuilds. Lots of very interesting things on this channel. It's about all things electronic, so let me be your electronics for ham radio only. I'll pass my knowledge on to you. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, I have an ongoing electronics course on Patreon. You're definitely going to want to check that out. I also share my inventions and designs up there as well. I'll put the link just below the Show More tab, below the video's description, and I'll also pin the link at the top of the comments section. So if you click on the links, it'll take you right there. If you're enjoying this channel, don't forget to hit the subscribe button and tap the bell symbol as well. Tap the bell symbol, you'll be notified as soon as I post a brand new video here on YouTube as well. Alright, until next time, take care. Bye for now.
Where they made it demanding moving at the next president. Thank you. That they raised the gas tax.
Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Let's see if this 1940s transmitter will come to life and actually transmit what power we get out of it, and see if it'll make any noise. So let's get started. In the previous video regarding this forestry radio receiver and transmitter pair, we tested the receiver together, and the receiver, oddly enough, worked quite well with all of those parts inside. So usually there's something wrong with it, bad cap, bad resistor, bad tube, or something like that. In fact, I can't say that it perfectly worked. BFO didn't work, so the beat frequency oscillator wasn't working out. But it received extremely well. It was very sensitive. So when it comes time to restore that radio receiver, things can only get better. That should be quite the hot receiver. It should work very, very well. Now, I didn't want to test the transmitter, which is this thing that you see right here, because this thing is, I guess you could say, well, it's had some very sketchy work done to it. So somebody's been in here and they've done some things that they should have done quite a bit better. So what I figure we'll do in this video is we'll attach this thing to a current limited power supply, and we'll bring the thing upstairs and see if this thing comes to life. Now, what I'm going to do is I'm going to attach the antenna terminal into my service monitor over here, so this will not radio. What's going to happen is it's going to put output power into a dummy load inside the service monitor, and we'll be able to see how much power this thing makes. Then we'll be able to see if it modulates, so we'll be able to see if the mic input works on the front and if it makes any noise. So it should be a lot of fun in this video. So, as seen in the previous video, this the PA plate tank tuning capacitor is so loose that it just wants to go wherever it wants to go, and that will not work. So that needs to be fixed, and that can very easily be fixed by removing this knob and then just putting a tension washer underneath it for now. There is other ways of doing it. I'll show you this here. This is a little trick. You need to be very careful that you actually do the right thing. or you can damage the actual capacitor itself. So I'll tell you the trick. So when these things get really loose, you can see how loose this thing is, right? So there's a zoom on in. Focus over here so you can see what's going on. Okay. So you'll see that there is a bunch of nuts in here. So all we basically do is remove this thing, and so desolder a connection on the other side there, remove this thing, which we'll do when we restore this, and loosen up the nuts on this side. So there's one here and one on the other side, and all you do is you move this one nut right here. This one nut here, give it about a quarter turn in. Worst case scenario is half a turn, and then we do the exact same thing with the one on the other side. The other side looks exactly the same. And what it does is it moves this ceramic wafer in ever so slightly, and that puts tension on the back side here of the rotor. And by doing that, what it does is it tightens things up. Now you don't want to move this one, because if you move this one, you'll put the stator, the stationary portion of this capacitor, out of alignment. And what that'll do is that will cause these plates to touch these plates. They can't touch each other. This needs to move freely inside the stator. So the rotor has to move freely inside there. And you can see that there's a very small gap in there on each side. So by moving this in, all that's going to do is put just a little bit of tension on this. Now you have to be very careful. If you move these too much and you tighten this up on this side, you'll crack this ceramic wafer that's holding this little strip here that's going to put tension on this. Okay, so you need to keep that in mind. So only usually a quarter of a turn or something like that, maybe a half a turn at max, and that'll cause this thing to get very rigid. But for now, this is on the front portion here. On the front portion here, what I can do is remove this and just put a washer and a little, I guess you could call it a spring type washer in behind it. I'll show you what I'm going to do here, and that'll add a lot of tension to this just from now. So I'll go grab that stuff, and I'll remove the knob here, and I'll show you exactly how to do that. This works very well if you don't want to actually go and do this. Here's one of those tempered spring type washers right here. You can see how it has a bit of a curve to it, and that is basically a piece of spring steel. Here, a spring piece of steel. And what you do is you take two washers, put a washer on each side like so. As you can see, it makes a little bit of a sandwich there. And if I squeeze this together, you can see how it puts tension on that. So at that point, what you do is screwdriver here, remove this. So usually these chicken head knobs have a recessed area, and this one actually has a very deep recessed area, so this would work very well. A lot of them aren't that recessed, but that'll work even better. So all you do is you take this, put one washer on here like so, you put the spring washer in between, put this other washer on top. So now you can see I've got this here, right? You can see what that's going to do is that's going to pull this forward just a touch and push the chicken head knob back onto the front here. So do this. Let's see. So we'll have this all the way this way. Okay, so I'll put this on like so. And then what I'm going to do, as you can see, I'm going to push this down. So I'm going to make sure this is where I want it. Okay, so like so. It should be pointing at about 9 o'clock. Push that down like so. Hold that. And then tighten that up. And look at that. Just like that. Fixed. That feels about the same as moving this around in the back side here. In fact, this might actually have just a bit more tension. And it doesn't affect the spacing. The spacing of the capacitor will be just fine, as you can see. So nothing shorting out. And that can be tested very easily with just a standard ohm meter or continuity meter. All you do is you put one lead on the chassis and then one lead on this particular portion right here. You can rotate this, and if it beeps or if you have any continuity, then you know that there is a short to hold the plates for it, but usually that won't do that. So again, if there are issues with this, and you need to move the stator portion of this capacitor around and just loosen these nuts here, and you can move this back and forth. And a lot of the times, if you do that, you're fiddling with this for quite a while. Now, I've seen these things so bad that people have bent the plates and they're shorting, and they're bent at different areas, so they're kind of bent on an angle, so you spend quite a long time straightening this out, but this is in very good condition, so this hasn't been tampered with at all. The spacing is pretty uniform throughout the travel. So there you go, that's nice and firm right now, so that'll stay where it needs to stay. Dip the plate down. Alright, so when I said sketchiness, as I was talking about before, if you're just joining in now, look at this, how this is put together. Look at the line for it. The capacitor here on the bottom, will just move this down just a touch. Capacitor on the bottom is just black taped into the thing here, so there's some pretty scary work. This capacitor just shoved into the hole on the top side of the chassis. This just moves around like so. Just leave that in there like that. A bunch of taped off wires. Should be kind of fun to see if this thing does come to life. So what I'm going to do is I'm going to warm up the service monitor right here and get some cables hooked up. Let's see if we can get anything out of this transmission. Okay, so the first thing that we need to do is turn on the service monitor. Let this thing warm up for a while. Alright, so it says we're on receiver test. We're on receiver test. We're going to be on transmitter test. It's on FM. We don't want that. And you can also filter around a little bit there. Put some noise into it. So let's see what else. Let's give it a scope display. It should be a lot of fun. So what this is going to tell us is we'll be able to see the frequency that this thing is transmitting on. So we can see how accurate that rock is in there still. We can see the power output, and if we feed modulation to this, we can see the mod frequency and level as well. So it gives us everything we need to see, and we can see what that mod looks like on the scope. So it should be a lot of fun, especially with all the hacked up wires and everything in here. You see? Modulation transformer sketchiness going on right here. So it should be a lot of fun to see how this thing comes to life. So what I'll do is I'll get this thing plugged in and I'll go from there. So what do you think is going to happen? Do you think it's going to make power output, or do you think it's going to do that in the form of smoke? That's fine. Alright, I've got everything attached here. I think it should be attached to this point. So this is my setup right here running into the service monitor. Slightly reactive. Touching reactions, and that's okay. It's a little bit of an anyways. So I've got this attached into here, and the power cord is now attached to the isolation transformer. So I'm going to do now is I have the switch on in front of this thing. So I don't know if this is for the lamp, because I haven't traced the wiring. I don't know if this is for the lamp or for something else, but this says on, so I'm thinking that it's to shut this off, so turn this whole unit. If there's no switch on this, it doesn't seem so. It might be switched by the receiver. Anyways, this is in current limit right now, and I should break the low out of this thing. It's in receive, by the way, the transmitter, the film I'm showing you. This camera movement, or the camera movement, it's in receive, it's not in transmit, so if I put it into transmit, obviously it's going to feel heavy current. So here we go. On it is. And that's a little brighter than normal. So not too incredibly bright, just a little bit brighter than normal. Any difference in here, on and off switch on. So it's not any difference there. So leave that in the on position. So this thing has no tubes in it, so you can't see any tubes glow. There's no pilot light, so I don't know what's happening right now. Let's flip it into transmit for a second. So move this down and down. Oh, yeah, it's definitely trying to transmit there. Okay, so this is a little bit, so I'm moving this around here. Like so, and as you can see, you can see a bit of needle deflection there, so it's trying to do something. So, it's current limited right now, so what I'm going to do is I'm going to let this thing, as you can see, sit here and baste for a while. So hopefully the capacitors are not going to go bad. I'm going to let the caps come up slowly, so I'm going to let this thing sit just like this. And if the bulbs stay dim, I'm doing good. If they get bright, I'll let you know in a little bit here. So between this shot and the next shot will be about a half an hour of me letting this thing sit and just letting the capacitors get comfortable again. That's all. So I'll be right back. Okay, half an hour has gone past, and the bulbs are still dim. So here again. Bulbs dim. Good sign. Flip that switch in the transmit again. Oh, we still got action there. It's drawing current, as you can see. The bulbs are at full brightness, which is a good sign, so that tells me that the caps are going to be okay. At least good enough for testing. Alright, so what I'm going to do is flip through switch, so it's going to bridge those bulbs out, and this thing is going to get full line. So here we go. Now this is still through an isolation transformer. I'm currently limited variac supply, so this is all still isolated right now. So the tubes themselves should come up. The filaments inside should be coming up to full brightness right now. And just a little transmit to see what happens. Oh, we got some pretty good plate current there, and the bulb is lighting up. So if you saw that, look at that. It's doing things. All right. So this is going to get into what it needs to be. So what I'm going to do is I'm going to put the focus on the surface monitor here. And keep an eye on that. Okay, so the focus is on there. I'll zoom in onto this here in just a moment to see if I can dip this thing very quickly here and get some form of power output. So I'm going to flip this thing into transmit. And so that's we do have a dip. He's going to steal that dip. So it's looking to me like so it's oscillating here. It's doing something. It's got power output. It is drawing quite a bit of current. And you can see the surface monitor is moving around. So it looks like it's trying to parasitic oscillate or something down here. So I'll just shut this off for a moment. So what I'll do is, now there's an antenna tuning control inside here as well. So we have the plate control here and the antenna control, antenna capacitor in the back here. So since this is going into a non-inductive load, it's really not going to do too incredibly much. What I will try to do is... So what I'm going to adjust is popped up. That's not a big thing for back on. So what I'm going to do is try doing an antenna adjustment here just a little bit, so I can stop this thing from oscillating. So it's not going to affect too much, but it might affect the oscillation. That neutralizing control on the underside of the chassis that I talked about in the previous video is probably part of the adjustment. So let's just move this around a touch. So insulated screwdriver up here, this is attached to the chassis wall. So here we go. And just move it around a little bit. This side, and it still wants to take off. And let's see, taking off, it just goes off to one side there. So it gets right to, you can see the bulb gets to a pretty bright state here, and then it wants to take off. So there's this over here, so Okay, so now what I'm going to do is just walk on the receive here. So what I'll do is I will adjust the coupling between the oscillator and the drive or the output tube here. So now there's a good chance that that is hot with RF and B+, so I'm going to use an insulated screwdriver and come in from the top side, like so. Okay, so it's back over here so you can see what's going on and see if I can slow down that parasitic oscillation that's going on there. Okay, so here we go. This is the one I want to move, not the other one. There's multiple points that it wants to take off. Okay, so now what I'll do is I'll adjust the actual crystal control, which is in the back over here. Focus on the receive. I'll adjust this control back here, and we'll see what's going on. See if we can slow it down just a little bit by doing that. So what I'll do is a little bit less. So this screwdriver here is insulated up here, and there's a little bit less metal. So. And here we go. Let's try it again. So put this in here and backside. And try and just kind of move it. It is. It will move. So let's try this out here. Okay, so it's drawing pretty heavy current there. So I'll set that at 12 o'clock, about halfway, and I'll move this crystal controller around just a touch. So even me poking this little piece of metal into there is causing it to do that. I'm not getting a whole lot of power output now. So I'll shut this off for a moment. See if I can move this with a plastic end. I can't. It's too big. So let's try this one. Right down there. Is it going to move that without destroying my tool? Probably not. Let's try this one here, which is insulated. That one there. Okay, so let's try again. Here we go. I got 5 watts coming out of this thing, and it's a little bit more stable right now. So you can see even me just putting this screwdriver in here is affecting it. As you can see, it just wants to take off. And it wants to take off. So that could be a tube issue. It could be a fact that, there's just so much, what would you call it, butchery under the chassis that it's just doing this. Everything on the top side is shielded here. What's towards the bench isn't. Sitting this on something metal might help that out, but this is still exposed when it's inside that case. The whole bottom portion is still exposed, and there's quite a bit of area between this and the receiver. Actually, no, not correct, because the receiver sits. No, that is right, because the receiver does sit on the bottom and this sits on top. So this is quite a bit of exposed area on the bottom, so that shouldn't be it. So I think that it might be a tube. Let's find out. If I can adjust the coupling now that I've adjusted the crystal, and we'll see if I can make this slow down. I would like to be able to stick a screwdriver in here and move this with something insulated, but the problem is this is so incredibly rigid that it's going to wreck my tuning tools. So, That's just going to destroy tuning tools. Give me a sec here, I'm going to look for another tool that might fit that. It'll be a little bit more insulated and not so incredibly conductive or magnetic. I'll be right back. Alright, I managed to move this into a spot with this ceramic screwdriver. I had to be very careful because these things, they just chip and break. So I got that into a sweet spot where this wants to somewhat transmit without getting too... See, look at that. It's not doing too bad right now. It's still taking off a little bit. It's still trying to take off. Kind of just doing this on its own. You see that? I wonder if one of these tubes is... Maybe that's 6x6. Or it could even be a resistor or a capacitor that's going away under there. So anyways, we're getting about 7 watts now. Isn't it? I'll zoom on in. It's about 7 watts coming out of this thing. About 6.7 watts. See, I'll move this around a bit here. See, make sure it doesn't take off anymore. 7.2. Taking off on me here. Nope, no, it's about 7.2. And I think that's just outside the dip. Oh, 7.3. So about 7 watts this thing is making. And it's holding somewhat stable now. I think it might be that 6v6. Doing a little silly. You see that, what do we got for plate current going on? We got about 70 milliamps, about 70 milliamps, maybe 70 and a bit milliamps down here, and here's over here, so you can see that kind of, so about 60, 70, 80, 75 milliamps, something like that, happening in there. So not too bad, and you can see the power output here, so is this the, I don't know what that on and off switch is for. Maybe modulation on and off, or maybe that's for the zero beat. That might just turn on the oscillator portion of this thing, so that you can zero beat this into the receiver, so that you can align the receiver and the transmitter. That might be that, or that might even be an intermediate setting on the control down here. So a bit on the control, so that might be the middle setting. So, because this is receive, and then you need to be able to align the transmitter to the receiver so that you can get the receiver and the transmitter on the same frequency. So that might be this position, or it might be this thing. So that might be to zero beat the receiver into the transmitter. Again, unknown until I draw this thing up. Who knows, right? So I'm actually quite amazed that this thing is even making 7 watts and not making any smoke at this point. Alright, so what I'm going to do now is I'm going to put a tone into the jack in the front here, and let's see if this thing will modulate it all. We'll be able to see that on the scope on the service monitor, which is just this thing right here. So I'll get that all set up and I'll be right back. As I was moving this thing around to attach the modulation to this thing, give it a bit of audio, you put a tone through it at any rate, things really stabilized. So I'm thinking that's really on. So I had my screwdriver, and I thought it was a 6v6, and I knocked the 6v6 again, and it started to get a bit unstable. So I thought, you know what, I'm going to knock the rock. So I did. I knocked the crystal a few times, and everything just completely stabilized. So there's probably the connections inside the crystal are oxidized. So really what it is there's a crystal between basically two metal tabs in there, and they're just pressed together. And you can see there's screws on the top side of the rock here, so I'll zoom on into that. You see right there down in the bottom corner of the screen, there's some screws on the top, so you can take these things apart and clean them up from time to time. Now again, this thing is going to be converted into the amateur radio bands, the ham radio bands, so this thing's going to go missing, and chances are this thing's going to have a VFO on it at any rate. But just knocking it stabilized it enough that we can continue here, and it actually put the frequency quite a bit closer as well. So what I'll do is I'll move this out again, and move the focus on the service monitor, so I'm going to movement of the camera there. So put this into transmit mode, and it's nice and stable now, as you can see. Hardly any movement there at all. You can see it runs in and out of the dip. So now, right in the dip, it's about, I would say 6.3 watts or something like that, right in the dip. You see right here, and the frequency got quite a bit closer too after I knocked it, so it's at 3.315 now. It was a little bit higher earlier. so it's very close to where it is, 3.315, 102, whatever. As you move this around and as things heat up, that's the last three are going to move around here just a bit. So what I'll do is I'll bring this just out of the dip. Now, as I mentioned in the previous video, you usually get maximum power outside the dip just a bit. And as you can see, you get this thing up to about 11.4 watts or something like that, now that the rock is working correctly. So you want to run this right in the dip. And of course, at that point, it'll modulate quite a bit easier as well. So right about there is the dip. So I'm not sure if we can even peak this thing up even better. Put this into the antenna capacitor here. And again, this is into a non-inductive load, so it's probably not too much of a difference. I'll say bring this out of the dip. Let's move this around just a touch. Yeah, out of the dip, you get about 12 watts. It's flickering about 12 watts completely with that one old 6L6 there. We'll just leave it there. So, you know, not much of a difference. Again, it's still into a non-inductive load, right? So, with my slight bit of added reactance over here. Let's see, what else can I say? Okay, so now it's about time to try and modulate this thing. So what I'm going to do is attach a tone to the microphone jack here, and we'll see what happens. So I'll get that all set up, and I will be right back. I have my cable attached to my low distortion audio signal generator over here, and this is also a signature tracer or curve tracer if you like. This is one of the projects that I released on Patreon quite some time ago. It's a $5 basically a junk oscilloscope that I picked up from a swap meet that I've turned into a curve tracer or signature tracer and an audio signal generator. So this is used for signature tracing, and it's also used for providing audio if you're working on guitar amplifiers or anything that needs some form of an audio drive signal. This is a low distortion source for that. So all the plans to build this thing and all the schematics and circuit board layouts and everything are all up on Patreon if you're interested in putting something like this together for yourself. Very handy tool to have around, and I'll use this thing all the time. It's what's on the bench right here. So this little block that's plugged into it is protection. So what this does is this protects me from zapping the front end of the signature tracer slash audio generator here. So if I make a mistake and I touch one of the leads of the cable here to something that's, you know, got a little bit of excessive voltage on it, it won't hurt this unit. It'll actually protect the unit and block that from going back in. The design and plans for this is also released up on Patreon if you're interested in building something like this for yourself. So what I'm going to do here is I'm going to attach this in the circuit, and what I'm going to do is vary the audio gain control here, okay? So, one other thing that this thing does is keeps this thing awake. So this will go asleep. That's another circuit board that's inside here, another design upon Patreon that will protect this old oscilloscope. So what it does is it pulls the trace off the screen if it's not in use for a short period of time. And all you do is you just touch the leads together and it wakes it back up and everything comes, you know, back onto the screen here. This keeps this awake for audio use as well. So it does a whole bunch of things. At any rate here, so what I'll do is I'll move this down here and I will show you where I'm about to attach this. So this is the microphone right here. Move your focus onto that. So this is the microphone input jack right here. And what I want to do is just find a comfortable ground here. So this, sometimes these jacks, when you pull the mic out with ground out, this just floats. So the connection inside here is just floating. So with the mic in or mic out, the center conductor here is just floating. So what I'm going to do is I'm going to attach this in the circuit without poking my hands in here, because this is a vacuum tube circuit and there's going to be high voltage around it. I do not want to come across that. So I'll find a nice convenient ground in here. Right down here looks like a good one. And there it is. And I will attach this to the microphone input right here. I'm far enough away from everything at this point. And turn this thing on to transmit and see if we get any audio. So keep an eye on the service monitor. I'll move the focus over to that. And if it does do anything, I will zoom on in. Not really. Move the gain up and down. Now, there should be drive there. There is a lot of audio drive coming into this thing. So there's nothing going through that transformer in the front end. So this goes directly into a coupling transformer, or interstage transformer if you want to call it that, coupling transformer. And then that runs into, comes out of this wire here, and then it will go into that potentiometer right there, as you can see. It comes right out of this wire. Goes into that potentiometer, and that goes into the grid of the 6C5. And that would be the wiper, which is right there. Goes to the 6C5. So what I'm going to do is I'm going to bypass that transformer, and I'm going to go directly to the grid, and let's see if there's anything wrong with that transformer. So this is the RF line right here. So I want to try and keep this away from that. So this is de-energized right now. So I'm still going to use my wires to get way down into the chassis here, because I definitely don't want to come across anything in this. I'm pretty sure the B plus is pretty high in here. You know what, just for the fun of it, let's see how much voltage is floating around in this chassis right now. A bunch of probes here, off to the side. This won't take me too long. Okay, so turn this on. So this actually needs a little bit of time to warm up, but it'll be off by 0.3 of a volt. So I think I can live with that right now. Put this onto the chassis here, round that to that. And we have the probe here, we're on DC volts, are we? We are. And let's see how many volts is on the rectifier. So, any guesses? Let's see, what do we think? Maybe 450? Let's see. I'm not seeing anything here. Transmit. 414. So there's 414 volts of B plus on that rectifier. So this is obviously switching the line to that, to the either maybe grounding a center tap or doing something at any rate to turn on the B plus over here. So it's the B plus is switched. And we just learned that right now. So there we go. That transformer has to be on because the tubes have to light up. So the chances are they're maybe removing the center tap or doing something like that at any rate. Who knows, maybe they're even switching it right at the high voltage level. I don't think they would, because it would probably arc in the switch. But yeah, you can see here, nothing. And then, some focus on this there. Nothing, and then switch on. 414 volts. So that will move around. If I draw more current, I'll probably pull it down. See that? Right in there. We're going to dip a bit. So the dip is the lowest amount of current that I'm finally be pulling right there. So there we go. 415 volts, something like that on that. So definitely don't want to be poking my hands around in that chassis, right? Come across that, and I'll have a pretty bad day. Okay, so now the audio is hooked up to this thing, and it's hooked directly to the grid, so let's find out what's going on. Actually, I'm seeing something here. Let's see, move the horizontal together a bit. So I got 14% mod with very low drive level, so I'll turn the drive up. It's modulating, so there's something not right with that interstage transformer. Somebody probably cooked it, putting something in the input. Look at that. It's modulating to pretty much 100%, and it's clean. So turn that down. That's it changing ranges when you're seeing it do that there. Look at that. It's not too bad, you know. Not perfectly clean, but you know. There's a lot of stuff going on here. These caps are probably bad. Who knows what else is happening in here. So it's right up to 100% mod. Switching ranges here, I can't deal with it. So there it is, 98%. So it's hitting 100% modulation. Just turn that down. Source monitor doesn't like that. So there you go. It's actually modulating. So an audio signal could be fed directly into the grid here if that interstage transformer wasn't needed. Again, that interstage transformer, I'll just turn this on to receive, and move this out of here, and put that back on to here. And as you can see, there's just nothing happening through the interstage transformer, right? So it's back into transmit here, turn that back to receive, and move this right directly to the grid. So effectively, I'm just bridging out that transformer, going directly into the grid of the 65, and there you go, right? We have audio, right? So somebody probably attached something to this interstage transformer and maybe cooked it up or something like that, or maybe there's even something else in the circuit, maybe there's some short somewhere else. It doesn't look like it, but who knows what's going on. So the interstage transformer could be changed, could be so many different things. Might have had some other use and somebody's done something. It's like, look at this thing, right? Who knows what's going on in here. So the bottom line is, it works. And basically, if I wanted to, I could, throw another rock in here and put it on an AM frequency and just leave things the way they are, clean it up, of course, and use the thing. It's modulating to 100%, fix up the audio section, and away it goes. So technically, the receiver and the transmitter from that old Forestry receiver and transmitter setup both work from 1940 something or other. Pretty amazing. So I'm looking forward to the restoration of this, so definitely stay tuned for that. We'll restore the receiver and the transmitter and put it in the amateur or ham radio bands. That should be a lot of fun. Then we'll make some contacts together too. It'll be great. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid-state electronic devices alike. There'll be a lot of repairs, restoration, circuitry design, all sorts of things revolving around electronics, because that's what this channel is all about. So if you're interested in seeing more of this stuff, don't forget to tap the bell symbol and hit the subscribe button and do all that stuff that YouTube wants so that you'll get notified when I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. Suitable for all levels and projects there for you to build and all sorts of neat information that you won't find anywhere else. Definitely check it out. I'll put the link just below the Show More tab, and I'll also post the link at the top of the comment section. So if you click on that, it'll take you right there. All right, until next time, take care. Bye for now.
Well, good morning, everyone. We have a crazy thing happening today. I have not attempted to replace a CPU on a laptop motherboard before, and I decided to try it live in front of everyone. So, it's probably going to be an epic failure. Not a big deal. It's all part of the fun, part of the experiment. But how's everyone doing today? Oh man. Yes. This is going to be a good one. Let me have some more coffee. I want to know how many people have actually attempted this before, because replacing a CPU on one of these motherboards is not an easy feat. I know that there are companies that do it, and they do it with professional machines. I don't have any of that, right? So we're going to be doing something that's a little bit interesting, because I don't have like a big VGA machine, and I have basic equipment, and that's kind of the idea. Can you actually remove a CPU, transplant it, reball it, things like that? I have thousands and thousands of hours of soldering, but I've never actually done a CPU transplant. So I'm just waiting for everyone to kind of pile in here. And so there's no vote for a machine today. This is going to be kind of just a mess around and see what ends up happening. And I've never ever attempted this before, so ever. I was thinking, I was like, I'll go ahead and do this on the, before I try to do it in front of people, but then I was like, what's the fun of that? What's the fun of that? Let's just go for it. Let's do it. So I have two boards here, and we have, this is one that I know that, I think we might have done this on stream a while back, I have no idea, but this is one where the CPU is bad for sure. We had a bad MOSFET on the CPU, and then it fried it out, so the CPU is shorted, so we know the CPU is bad, okay? So that's the easy part. And I have stacks of these boards. I probably have like 20 or 30 of these motherboards. The issue is finding a good CPU. So I have JFix, how you doing, buddy? I have this board that is a good candidate. Probably it has the same CPU, and it's an SR320, I think, is the number on it. So this is like a 7th gen processor, or 6th gen, 7th gen. Actually, I need to make sure it's a 7th gen, so I think it's the only thing I have a stencil for. Let me see what stencils I have. So I picked up some stencils last month, and don't knock things over here. So we need to make sure we have a stencil that does fit it, otherwise it's a kind of a waste of time for this whole thing. And push it back, but these are all generic stencils. Those are VRAM stencils. Where is the stencil? I should have had all this prepared ahead of time, but it's been a crazy morning, the weekend. Sorry, I'm going to keep digging around for you. So if you watch Northwest Repair, he replaces GPUs all the time. He pulls these things off, puts them back on. Now the main thing about doing that, this is like, if he has a machine, like, here's how I want you to kind of think about it. So what he's doing is he's removing the GPU core, reballing it, putting it back on. So he has a core that may or may not work properly, but he's just reballing it to fix any traces underneath. What I'm attempting to do is actually try to find a CPU that works and put it on there. And see, that's the problem. That's the problem. Anytime somebody's like, just replace the CPU, well, where do you get a CPU that's good? Right? Just because I have a bunch of donor boards, these things have a tendency of having a lot of bad CPUs because of the way they fail. So, we could just take it off, take a CPU off, put it back on, and see if that even they do what they do. But I still need to find that stencil. What did I do with those? Sorry, I'm going to dig around for a second. You guys talk amongst yourselves. I know I had these stencils. Okay, here we go. Here we go. Oh yeah, I haven't even actually used these. I forgot that I bought this. Who did I see? I think Nanofix had these. Somebody had these, and I ordered some. I like the design of it. But I don't know if this was a good idea or not. I don't know, because I was thinking that I was going to be using the pre-made balls and just shake them on there, because that's what I usually do for if I'm doing like MTV RAM and stuff like that. But these are kits for reballing GPUs and CPUs. Let me just kind of show you around. And again, I haven't used them yet, so it's all going to be a trial and error. Wait, Montgomery, did you see the image of the Dell laptop I hacked? I sent it to you. I don't. If you sent the email, I haven't checked emails yet, or I haven't checked them today because it's the weekend. So no. So yes or no. All right. So these guys are reballing stencils, and what's cool about this little jig here is that it has. It has the stencil. I want to move this board out of the way. These are the stencils here, and then this is a heavy magnet. And then you're able to set this down. You put the chip in there, and then you set this on top of the magnet, hold it tight, and then you're able to put your flux or what is it? Solder paste on it. So I have a couple of different versions of this. This is actually for the. What is it for? This is for a 3060 GPU. And this one's for a RX 580. And then I got a couple more. Like I'm not planning on doing any GPUs right now. We're just kind of messing around. This is for a RTX 2060, 2070, 2080. And then this is supposed to be for the 7th gen. 6th and 7th gen i7. Oh, so yeah, okay, so this was for an SR32S. I wonder if it only goes through 32S. That'd be kind of annoying. So this chip here that we're looking at replacing is a 320. Where's it say? Right here on the edge, it's hard to see. Right there, SR320. Can you kind of see it? So 320 and 32S, are those totally different chips? I don't know. I was kind of thinking that this was kind of a generic stencil for a 32S, or a 32X is kind of what I was thinking. Well, this could be completely useless, but pulling them off might be still entertaining, right? I think we can still get entertainment value out of pulling it off. So I think that's what we're going to try anyway. So whether we're able to reball it and put it back on or whatever, that's kind of what I want to look at. Hey, Lifeless Creator, you are spamming the chat. I know if you're trying to get me to read it, that's not the way to do it, because what's going to end up happening is somebody's going to press a button and get you out of there, so don't do that. I'll see if I can read through the chat for a little bit, and then we can start doing stuff, because we're going to basically have to put this on a preheater, and it'll take a long time to heat this thing up. And my original plan was, this is the bad CPU, bad CPU, and my original plan is to pull the good CPU off first, and then have that set aside, reball it, and then we'll do the bad CPU next. So that's probably what we'll end up doing. That way we have, the one already prepared. Because otherwise you have to pull the bad one, then pull that board off, and heat this board up, but then you'll reheat this one to put it back on. So it doesn't make sense. Get them, mods, get them. Darren, yeah, that's right. So, if you have any questions, about pertaining to a repair, so in this stream, in general, I'm working on repairs at the same time. I cannot answer your questions about repairs in general, and maybe if we're in a just chatting type of state, but if you want to ask a question about something, we do have the Discord. JFix has a Discord. You can do !Discord. Actually, update the link. But !Discord will get you the link to the chat. And hold on, let me see if I can update, make sure I have the most recent link to the Discord. Put it there. So the Discord link is updated. So exclamation point Discord will get you a link to our Discord, and then you can ask questions in there. Okay, so here's what I want to do actually. I'm just kind of all over the place, but I've thought this through a little bit and tried to figure out exactly, what we need to do to actually make this thing happen. There's a few different things we need in order to get the CPU off, and so we need things like a preheater, and the only preheater I have is a little baby one. So the issue with that, this board is huge. And so we'll be able to put the CPU die over this heated area here, but it will be hanging off. So there are going to be some areas that won't get as hot as others, whether that will affect the whole process or not. The real way of doing it is you would heat the whole board. You would have a real, actual machine, more or less, that would be heating it at a nice pace, a certain pace that you don't overheat things too fast. And that's not what we're doing. I'm going to basically put this at full bore probably, because this little guy does not put too much heat out. This is these things are cheap. Was it 853A? 853A. So I can put this thing at 400C, and I still would not be able to get this board to 400C. And I really just need to get this board to about 200, and then I'll finish it off. And so this is actually probably going to be able to get the board to maybe 130 or 140, maybe. So we're going to put thermal sensors on it, and that's the other thing we'll need. So we need to know what temperature the board is at. So I have one of these guys. This is just a dual probe. It has two thermocouples that we can strap onto the board. So I'll usually strap one to one side of the board, one to the other side of the board, and that way we can kind of see how the board's nicely heating up. The last thing that we'll need is when we're reballing the chip, I use one of these little tiny chip preheaters, and so we'll pull the CPU off, we'll set it on here whenever we're reballing it, and that will help us melt it. So those are the things I have, and then we have a few different of these things that are for the hot air station. None of them are the right shape. So this one's too small. Put it over the CPU. It's a little bit too small. And these two are more square. This one's probably the closest, and that's the one I'm probably going to use. It will get us kind of in a close setup, but probably not correct. Sounds like we're cooking a CPU today. So yeah, I don't care about these boards, so I'm not concerned. This isn't a customer machine. This is just for fun, right? Just for the excitement of doing it, and never have done it. That's also the fun part about it. So let me clear off some space. I'll get the preheater going, and then we can chat, because it's going to take a while for the preheater to do anything. So I think, which end are we going to use? I think I'm going to use that one. How much is the equipment to get started? Do not follow any of the procedures that I have shown you. There is no equipment to get started in this. I do not expect this to actually work. Okay, so I have premises saying that the SR32S stencil will work on the SR320 system. Thank you. Thank you. That will make it so much more fun, because then it's not a waste of time. So I'm going to get the preheater going. I should crank down the AC in here, because I'm going to get hot pretty fast. I know that. So we're going to pull the good CPU off first, but I want to put my probes in the right area. And we're going to set it up so you guys can see what temperature we have. At least that's the idea. You see it? Look it up a little bit. Okay, so these are going to be the two thermocouples that we're going to be paying attention to. I'm going to put one on the back of the CPU, on the back of the board, and I'm going to put one next to the CPU. It's practice, yep. And I could have practiced this off camera, and then I would have looked more professional if I ever did it. Oh yeah, and I want to also caveat this with, I do not want to do this for anybody else, ever. This is not going to be part of a service I want to offer, period. So don't try to send everybody to do this. I had someone call me, or actually they emailed me and said, hey, can you swap out a CPU for me? I'm going to buy a new one of these. I need to get it replaced. and they were going to buy a new one on Mauser, and this new CPU on Mauser was $500. So he wanted me to attempt to replace a $500 CPU on a board that I think we sold the board for $300. So I didn't really understand that in the first place, but just so I could practice. I think he might be in chat because he said he watched the live stream and we talked about it. So I don't know. That's not something that I'm interested in doing. I don't want to mess with anybody's machine or try to figure out how to transfer a CPU over. That's not worth it because it's hard to find a good one. Oh. Daryl says it's time for bourbon, coffee, and honey, honey, honey. Yes, sir. Yes, sir. All right, so I have this one kind of strapped in there. I don't want to cover up the back of the CPU too much because I want to be able to have that thermal, the heat go there. So we're just going to have that strapped right there. Black Horse bakes the board a few hours. No. Well, he has like a whole machine that actually has like a PC interface and everything. That's not what we're doing today. Where we're going, we don't need a PC interface. Yeah, bourbon will make the process more fun. So I want to get this in the right position too. And so this, again, this preheater is not even close to what I need for this. So I'm just kind of set it up here. I usually use this for smaller items, and then some of these motherboards are smaller to fit on here, but this one is definitely a big one. Probably not the best one to have as the first example, but I know for a fact that we have a stack of these boards, and I have a board that I know that has a shorted CPU, and we're going to go 88 miles an hour apparently. Where we're going, we don't need. I love Back to the Future references, by the way. Alright, so we're going to line this guy up to right here. So again, the purpose of having the thermocouple on both sides is so you can see what temperature the board's at. You don't want to start trying to pry out this CPU until you know the board's reached the right temperature. Now this is all based on me kind of watching and observing other people who have attempted this or have done this. So again, I've never done it. I just want to preface that with, do not follow my procedure as being correct. This is for entertainment purposes only. But I thought it would be a fun thing to do. Can we update my title? Yeah, because I still have the real and fake title there. Can somebody update the title of what I'm doing? And this could actually be, is this real or fake anyway? Alright, let's get that there. I'll put another piece of tape. How do you know if the CPU or GPU are bad? Yeah, well, I'll show you why I'm saying that this one's bad. So this motherboard that we know it has a bad CPU was a candidate during a repair that had a shorted MOSFET on the CPU. And the CPU is actually measuring shorted. So, excuse me. So we know that the CPU is actually shorted. And that's why. Sometimes it's hard to get these thermocouples to sit down all the way. Okay, that's pretty good. Okay, I'm going to turn this preheater on, and then we can start chat away for a little while, because this will take a while. I need to air conditioner up. So I'm going to just try to put the CPU right in the middle of this tiny little screen here. And let me show you how this screen is. So this is the front of the preheater. And so I can set the temperature to all the way up to 400 C. And I usually just like for smaller boards, I'm just doing like 300, and then that will usually get the board up to about 110 or something. I'm just going to crank this thing to full blast because I don't think we're going to be able to get even close. And I also don't think, so there's the actual heat plate or the actual coils heating up or whatever it is. I don't think that this thing's going to get hotter than 130 or 140. Maybe on the back side you'll see it will read a higher temperature, but the top side is not going to read as much. We're reballing the CPU today, Josh. Well, we're attempting to. Never done it before. Never done it. So do not follow what I'm doing. And I just realized that our Twitch counter is not working. So I mean, let's make sure that we have that going. Test trigger. See if that will start updating. We'll see if that starts updating. I don't understand why it sits. Sometimes Twitch sits at 0, sometimes it doesn't on my using StreamerBot. So I know it's delayed. All right, so that's heating up. We do see temperature actually rising on there. So we're at 39 on the bottom. So the bottom one is the bottom, and the top one is the top one. That actually worked out. How convenient is that? So while it's heating up, I want to show you. How can I do this? Because this is in my way now. Someone asked how I know. I'm turning the wrong. How do I know that this is a bad one? I'm going to set this on top gently here. Gently. So this CPU is bad, and it's because we're actually missing some coils on here. But we had replaced these MOSFETs here and removed these coils because we had a short. We were measuring a short on the CPU. And oh, 1.5. Didn't we? I was 99% sure this is the board that had a short, the 0 ohm. Well, regardless, we think this has a bad CPU because we know that the MOSFET is shorted. So I don't. I should have tested all this stuff ahead of time. It's fine. This is all part of it. The rawness of it. I'm gonna raw dog this whole thing. All right, so we can see the top of the board is heating up to 38°C, the bottom's at 74. Now, the bottom is getting the direct heat from the heat plate, so it's always going to seem a little hotter. I had the temperature of the preheater set to 400, if you can believe it, which doesn't mean it's going to actually do anything. I usually set it to a lot lower. Right now it's at, so the temperature says it's at 312. I mean, we could start it at lower, just leave it at like 300 for a while. Maybe that might be smarter. Let's do that. So I'm going to set the heat plate to 300. And then we'll let it sit there and let it come up to the temperature and see what it actually gets to if it's set to 300. But I doubt it's going to do that. All right, let me get back to chat. I'm going to answer some questions because this takes a little while. And I just got 100 SEKs. What are those? What are those? $10.66. Thank you so much, Wolfie. Where's that? Where are you from? Wolfie, where's SEKs from? I don't know what currency that is. All right, I'm going to go back and read some chat while we're at this. Swedish. All right, nice. Preheater, okay, Aussies, need two heat plates. Well, I have a top one too, so I guess I didn't explain that. So this goes on top, and then I'm gonna have my hotter station will go on top, and that will finish it out. We're just trying to get the board up to a certain temperature. Northwest Repair talks about blue specs in the new CPU and GPU. Okay, I don't know what that is. Can you repair an absent printer? I only work on Dell laptops. That's all I do. And printers are not worth fixing because unless it's maybe a $2,000 printer or something like that. But I don't work on printers. What tools do you use to reflash a BIOS chip? I use the T48 flashing tool, and which is this guy. There's a link in the video description, and it comes with software. Okay, so you can buy the link. You can get it the link in the video description. Raw dogging, yeah, feeling good. Raw dogging this morning. They secure the board while heating. I don't really have a way of securing it, so it's just sitting on top, and it's because I don't really have clamps to clamp it down. I don't know. I mean, maybe I can. I have some. Let's see. I think I have some of those clamps. I'm not worried about it today. This is all just an experiment. I mean, I really should have a double-sized preheater or a bigger one. I don't want one of those really big ones, but I don't know. And this Twitch counter is still not updating. Super annoying. I don't know. I don't know. Quite frustrating. Still says we have 0 on Twitch, and I know for a fact we have 30, so whatevs. Okay, sorry, I need to get back to reading some chat. This, I guess it's going to take a while. Oh, turned off. Make sure to tell me that the thing tells it turns off. Can I fix anything while I wait? Well, yeah, that should be hard. If I set this off to the side. Yeah, just let me know if the thermal couplers ever turn off, because they do turn off. Gritty, what do you use for voltage input meter on the top left on your desk? Does it have a power supply? My version is straight in and straight out and reads volts and lights. It's kind of annoying. Are we talking about the volt meter, like the DMN, digital multimeter, or are we talking about my little power box off to the side here? Wolfie. Or Gritty. I said Wolfie. Sorry, Gritty. 5 years with closed service. Yeah, maybe. I don't know if it's even worth it. No temperature readings. Oh, I'm back up here. People are asleep on Twitter. We don't count Twitch. Is it working yet? That's throwing errors up there. I can see it. Let me turn this. Oh no, man. I've done that. Let me add a new Twitch. Twitch viewer count. Chat channel. Add viewer count. I don't know. I don't get it. I don't get what it wants. I wish I could sort this chat better, because it's really hard to keep up with this stuff. Am I affiliated with Dell? I'm not affiliated with Dell at all. I'm not affiliated with Dell at all. I actually have to have a notice on the bottom of my website, on the bottom, so I'm not affiliated with the Dell Computer Corporation, because people are getting confused that I was Dell, and so if you actually search for Dell's support number or Dell, a lot of Dell different search terms, we come up. Even directory assistants was giving our phone number out for a while for being Dell. Will hot air reach the CPU on the arm? Yes. So the arm here, this is adjustable. I'm going to go wide angle side shot here. Oh, is that a better shot? So this little arm is adjustable, and then I can put this guy in here, and then we're going to be taking this little adapter guy and putting that in there. Not burning my hand. So this will mount in like this. And make sure it's the right height for the board. And adjust it. So this mounts in like that. I need to get the right height off the CPU, so it's not too close, not too far. Goldilocks. It's hard to get adjusted. And twist this. Where I go. And see how I don't. I can't actually. I have to move the board back a little bit to even get it in the right spot. So there we go. So we are lined up pretty good. Let's see, another camera. Here's more cameras. I can have a camera right here. Let's do. You can see it over the head, and then there's a side shot of it with this other camera. So the premise would be that I just kind of move this back and forth and heat it, and then I'll move it out of the way, and I'll be able to lift it up with a vacuum pump. Oh, I didn't show you the vacuum pump. I guess I showed you the other night that I had it set up. So this is a... Ruh-roh. The end fell off. That was my vacuum pump. Give me a second, I have to go under my desk. So this is my little vacuum pen here, and it hooks to a aquarium pump that's underneath my desk. And I'll be able to just pick up the CPU. Did I clean the die off? I didn't clean the die off. That would be helpful. How am I going to pick up that CPU if the die's so dirty? What do you think about that? So right now we still have this beer heater at 300C, and you see it's only getting the 96 on the bottom and 72 on the top. It's because we have so much, this is really thick wood, and so it's very hard for it to actually heat it. That's why we're going to overheat it, or actually put the preheater at a higher temperature. I'm going to clean this off so I actually have something to suction to. Is that the right size? I haven't tested any of this stuff. Barely. So I'll still be able to just grab it like that and pick it up. We also have some other stuff we need to address, which is these edges. We have this glue on the edges, so once we get heated up enough, we can start taking some of this glue off here on the corners. On which bottle are you trying to transplant a CPU? This is a 17R4 and it's an Alienware 17R4 and an Alienware 15R3. It's the same motherboard. Same motherboard. Boom. You have two VGA stations collecting dust. What the PS3 is for. Interesting. Well, are they big enough to do a CPU? I guess so. Yeah, I have no desire to actually operate as a service. Again, this is just kind of a fun little thing to do on a Sunday morning. You told me 3 times to clean it, huh? Well, thank you. It's hard to keep up with the chat. All I want to do is rock with you. We're singing a Michael Jackson song. The hot air station for a QFP, not a VGA, is it? Yeah, maybe. So, again, I don't know anything about this stuff, so anybody who's done this before, you can tell me. So is this absolutely the wrong one? Do we not want this? Do we want the one, I saw there's also ones that have the grill here in the middle. Yeah, we're going to clean the corner out of the glue when it gets heated up a little bit more, but I figured that we would do it later. Experimenting with brain surgery, I like that. That's maybe what the title should be. I heard you mention this is fun. For fun, we'll see if it functions after it's dead. Or if we transfer it. I don't think it's going to function. I just want to take it off and see what happens. Do you think it's possible to swap a chiplet in CPU by your current tools? I don't even think it's possible to do what I'm doing with my current tools at all. I don't think it's possible. Is it an i7 or an i9? I'm pretty sure that somebody else can answer that question. I think it's an i7. Pretty sure. So we've reached 100 degrees C on the bottom and 75 at the top. But we're leveling out. It looks like we're just kind of sitting there. So now I'm going to crank this thing to 400. So that's just going up to 300. See, we didn't even get above it. So now we're at full heat at 400, and we'll see what we can do. Anyone excited for me? I would hope not. I hope people want to see me fail. That's all. That's why people are actually joining in here. Well, they're joining in for me to fail down. Why won't my Twitch thing update? It's driving me crazy. I don't know if I need to just reconnect to Twitch or not. The Twitch chat's there, all this stuff. Here, I'm gonna see if I can reset my Twitch login again. See if that fixes it. There we go. All right, hopefully that will. Oh yeah, look, it updated. Look, immediately updated. Okay, so that's the trick. If we ever have 0 Twitch viewers, I just need to log out, log back in on my streamer. Solved it. Is Black Horse in the house yet? Because he's going to tell me how to do this. Black Horse actually has been making his own flux and sending me some right now. I could have waited for him to send it in before I did this, but you know, we got to use what we got. Maybe we'll use NF flux. Wrong nozzle. So it is the wrong nozzle. Do we have concurrence? Does everyone concur that it's the wrong nozzle? I fixed it. All right. So what nozzle should I be using? So I don't have very many choices. So should I just raw dog it with just an open end, or should I actually have one of these nozzles on it? That's the question, people. Okay, so you want to have one that has the full mesh in the middle and not having just the ends for the QFM style? Is that what you're saying? Yeah, Gumball, I'm attempting to transplant a CPU for fun, for science. Just do an open end. I just hate to blast the CPU so much, but yeah, open end will probably be fine with me. So I can do an open end with just the end like this, or we can put the adapter which goes to these on there, which will still give it a nice fat open end. But if I did that, I guess it would disperse better. The chat will tell me, because I knew you guys would know more than me. And we're up to 120 on the board now. Yes, open, raw dog. Raw dog. I just want to get this darn thing off of here. I just want to see what it looks like, and then see if we can even reball it. Kind of cool. It's a big CPU. I should have started with something a little smaller. Keep it above 1 millimeter of the CPU at least. 1 millimeter is really tiny. I mean, I hate to be right on the CPU die. I concur with adapter. So we got a with adapter. And then some are saying without adapter, right? Without adapter, we got with adapter. So that's not super helpful with me. So if we did. So let's see if we can see it. So here's the end without it, and here's the end with it. So it would have just a big nozzle, and here's the comparison to the size of the CPU. So if I put it where I'm heating this area, it would kind of focus it more in one area. If I did it where it didn't have the end on it at all, it will kind of disperse the air more around that whole area. I'm thinking no end on it. We need to call Northwest, yeah. He needs to tune in right now. It's a Sunday morning. What else has he got going on? Big Bala. Northwest Repair uses an open nozzle. Okay. Well, then if he does it, then I'm doing it. I'm going in. 3 millimeters over CPU, so it's concentrated. I like that. Okay. Adapter makes no sense. Okay, so we're gonna let me see if I can get this lined up right. I'll go back to widescreen so you can see the side shot. So I'm gonna lower this down to try to get the right height. Somewhere around there. And then I can go back and forth on it. Right? We can do it like that. Does that sound good? I think that's good. Okay, so we need to get this glue off. We still need to remove the glue. Use the adapter and concentrate the heat. So should we do a poll at this point? Because I mean, I'm thinking no adapter, and then we're still getting kind of a mix. I think no adapter, and I'm just going to be kind of sweeping back and forth anyway. We're just trying to get this heated up. The bottom of the CPU is right now heated to 127, 128, and it looks like we've kind of maxed out our heat. So our that's as high as we're going to be able to get it. So whatever heat we're going to be adding, we're going to be adding it from the top now. And so hopefully we'll be able to get the board hot enough. I would ultimately like to be at like 180 on the bottom. So we're only at 125 on the bottom. Either way, it's going to be interesting. All right, let's see if we can get this glue off of here. And I don't know the technique for doing that either, so someone's going to tell me. I just was going to scrape it. So the glue in question is right here. It almost looks like hot glue, but it's some sort of rubbery substance that's a high temperature gas. Hey, it just comes right off. Look at that. That was not hard at all. I'm just going to raw dog it down. I think it's because of what's hot. That's why it was a good idea to preheat it before we did this. I feel like we need some music, some suspenseful music. Okay. All right, so this is supposedly the good CPU. Supposedly. But I don't know. I don't know. Yeah, so we might need to update the title that we're raw dogging a CPU replacement. because ain't nothing gentle going on here. We're not doing it slowly. We're not doing it bellissimo. Probably should start adding some flux to it at this point, I guess. And the crowd goes wild! Alright, so then the next question is, I don't have a lot of flux choice. So now we need to figure this one out. So we got NF flux, the old NF dot, which I've heard is not good for that. 559 Antec, and then the 213 Antec. And then the black horse stuff is coming. I don't have it yet. I was just going to use 559, that's what I was thinking. Hello from Greece. Why on earth are CPUs soldered anyway? Because everything's integrated on motherboards these days. Look like silicon glue, yeah, probably. Yellow tape is capped on tape, that's correct, and it's legit capped on tape. It's like $80 a roll. 559, 213, 213, 213, 213, 559. Oh my goodness. And then flux will give the best results. LOL. It is the best stuff around, and you can buy it any day. Ship same day sometimes. Attempting to do a first CPU transplant raw dog style. Is the Discord thing not working? Darn it. I thought that exclamation point Discord would work. It shows up every 30 minutes to link to our Discord, so... Nate's voice impression. There's probably pretty bad. I'm sorry. I never practiced it. Okay, I think we're ready to start doing something, so I'm going to start putting some flux under here. So I'm going to go 559. We could do a poll, but we should sit there and do a poll. We just need to start putting some flux under here. And this stuff should run and seep under there perfectly. See how it's kind of sucking itself in there? You know what would be interesting is what if we put 559 on one side and the NF flux on the other side, and see if we get a bunch of whip pads on the other side. Because I don't care about destroying this board. What do you think about that? I don't know. So I'm just trying to get it to seep under there and suck under there. And it's hard to get this microscope focused because it's so high up. And I'm having a hard time getting it underneath here. Or high enough away from it. But you see how it's sucking under there? It's perfect. So do you think I should do half and half, or should I just do the whole thing? You don't need no steeping full. Just pure? Okay. We'll just do the whole thing. This whole thing is just an experiment. Yeah, I'd rather be able to get it all. I'd rather do it. So See how it's sucking under there? That's really good. And I know Northwest uses the really cheap flux for this because then he doesn't have to use like expensive stuff that cost him $1 billion. I feel like I got enough under there already. Okay. Yeah, it's like no more can go under there. It's a very thirsty CPU. I wonder if I can raise this microscope. Let me see if I can do that. Because I can't get it high enough. Whoa, pick this thing. Alright, let's see. Alright, now it's a little more focused. This higher up. But I don't know if we need to have it. I don't know, figure out what view we're going to do. Let's do the overhead view. I'm going to put this guy on here. I think it's time to start heating this. So we need our thermostat. What our temperature is at. This is, again, we have our heating plate at 400 degrees C. And so the bottom temperature you're seeing here is the bottom temperature is on the bottom of the board, and the top temperature is on the top of the board. And we're at 400 C on our heating station, or our preheater, but we're only getting to 130. So you can tell that this thing is not being able to heat it very much. So now we're going to heat it with, I don't know, I was going to go 300 on the top. I'm assuming that's enough, but maybe we need to go 350 on the top. Maybe we'll do 350 with a lower temperature. Our lower airspeed. We'll see. All right. Here we go. And I don't know what view y'all want, so I'll just kind of jump around. So we're doing 350. And I can actually see the stuff starting to boil. You can't really see it there because the focus is wrong. Maybe we should go microscope? I don't know. I'm trying to figure out what views I have for you guys. I do see some boiling going on. See if I can get this microscope lined up. Of course, I'm hitting my, yeah, I can't do it with the microscope at the same time because I hit the higher station, so that's out of the question. Sorry, guys. All right, so we're doing it. So what temperature we're at? We don't have the temperature on the screen. Okay, we're at 235 on top, 200 on the bottom. So what we're waiting for is that bottom. We need to get at least 220, right? 240 on the bottom. No, we need 220 is like the unleaded solder temperature. And so this isn't working. This is at 350 C, and we're kind of capped out here. So we're going to have to go up to 400 now, right? We're going to 400. Oh, I see some smoke. I don't have my air on. Darn it. Need some air. Give me some oxygen. Okay, we're getting higher. We're at 160 something on the top. But the bottom needs to be a little bit hotter, right? The chip's not moving yet. If you're just joining in, people, I'm trying to remove the CPU off a motherboard, and I've never done it before. Oh, the CPU's starting to move. A little bit. We're at 218, 219 on the bottom. And that should be the temperature of solder. The solder melted is like 220, right? 221. And so it has a hot air station at 400. Oh, the CPU's moving. It's moving. Okay, well, I feel like I can grab it. I don't know. We're going to turn it on, turn on the pump here, whatever it takes. 220, 221. All right, here we go. Nope, I couldn't grab it with that. My suction thing working? I might just need to hold the thing with tweezers. Look at that. I got it. Okay, let me turn this off. And the crowd goes wild! Oh my god. Okay, well, that actually was easier than I thought. Now the question is, how fat is our board? Is the board going to be bent? Is that what you're thinking? Show how bent the board is, because the thing is what people are looking at is that, let me zoom out. Let me get this hot piece of metal out of my way here. So you saw that right as we started getting the bottom temperature here, let's see. So there's two temperatures, one's on the bottom of the board, one's on the top of the board. The bottom of the board, once it started hitting right around 220, the CPU started moving. And so that's why we have a probe on the bottom of the board and we have a probe on the top of the board. And so we can actually see what temperatures are being exposed to the board. But what they're talking about is that my heating plate is only here, and we're heating this area really extensively. We really should have a heating plate that heats the entire board equally. And so this area of the board is not as hot as this area of the board, right? And so you're going to have a big warp on the board. So let's see if I can do this without burning my hands. So see if we have like a little cupping going on. I don't know. You can see it. I'm going to turn it the other way. It's hot, guys. Well, it's not as bad as I would think. But you can definitely see maybe a little bit of misshape. And so I can let this thing cool off naturally and just not hurry it up or anything. But I want to look at the pads here and see how we did. So we got. Is that a rip pad right there? Or not? Can't tell. No, that's not a rip pad. It almost looks like a rip pad, but I think that just needs to get cleaned. We should clean this, I guess, while it's still warm. We don't. This is just a board that we're just stealing this part off of, so it doesn't really matter what we're doing to this. But I want to try to clean it off so we can look at the pads, just so we can learn on what we just did. Get our learn on. And I probably should use a really big tip for this. Don't really have one access. Oh, there's one out there. Put a pot of coffee on. Alright, so I'm going to use one of these big daddy tips. I never use these. Check the technique. Alright, I can smell this burning stuff here. There should be enough flux on there, hopefully, to just clean this off. So the idea with this is you're going to be putting lower melt solder on here because the leaded solder, the unleaded solder that's on here gets at a higher temperature, and we want to try to clean this off. Again, this is a board we don't care about. We're just why can't I get this in focus? I can't get this thing high enough to focus. There we go. Alright, is that better? Yeah, it looks pretty darn good though. I gotta say, I'm proud of myself. We're just experimenting. Get my thermocouple out of the way. I don't want to solder that into it. Get out of the way. Okay. I'm just doing this so that we can see how bad off it is, but it looks to me like it's pretty darn good. I don't think we ripped a single pad. I don't think we charred the board either. Sorry, I can't see the chat that well, so if I'm not answering your questions, I'm very sorry. I am having a hard time getting all this darn flux off here, though. Alright, I just got to cruise around real quick. I just want to see how we did. Still hard to see with all that stuff in there. Do we have a polarizer on? So we can polarize it. Well. All right, not a single rip pad. So I think that passes the test of what we can do on the other board. But the next question is, let's see if we can reball this chip. Because this is a multi-hole stage process here. I'm just going to move this out of the way so it's not in my way. Yeah, cheap flux does suck, and so this flux was supposed to not be cheap. But the question is it even real flux? You know where I bought this flux from? This Amtech 559 that's supposed to be genuine? I bought this from Northridge Fix, who puts it in these syringes here. So we are assuming that they are legit. That's all I can do. All I can do is assume. I think you should put some Kapton tape to protect it in the future adjacent parts. Yeah, that's a good idea. I really wasn't putting any heat on any of the like capacitors around there or things like that, so that, but I still could. So here's our CPU. Of course you can't see it, but I can see it. We're going to do the same process here to try to clean this off. prepackaged Amtech syringes. Yes, that's always been a questionable thing for me, but he has a purpose, a reason, and I tend to try to like trust people. So that's kind of my process. So here's our genuine Amtech. This is some genuine 559 that I bought off of AliExpress. See the color difference? It's weird. No wait, this was 2 with red. Sorry. Here's my 559. So here's the 559. They're all different colors, so I don't really understand. So this is Amtech 213. This is AliExpress Amtech 559. This is Northridge Fix 559. And in my camera here, I can see that one's a little clearer, one's a little more yellow. So, oh, do we have polls in? Sorry. Will there be ripped pads? Oh, you did a poll that will there be ripped pads. Good one. Didn't even think about that. Why not buy Amtech from Mauser? Do they even sell it, really? I didn't even check. Maybe that's why. Yeah, I have an account with them. I buy multiple orders a week from them. So, that will be a good idea. Ouch! I'm showing my finger. Okay. It's going to be a reckoning? Is that what someone said? Oh, I reckon the most countable part is underneath the CPU slot now. I think the most difficult part is going to be reballing this, personally. Installing it shouldn't be an issue, but just reballing this seems like it'll be pretty hard. I'm surprised that I was able to get that darn thing off so easily. So right now we're taking off all the old solder. We're going to be putting it in our jig and trying to reball it with fresh solder balls because this is a VGA chip. And we need to do it just right so it will sit down and connect to the board properly. And we're assuming this chip is good. And I think when you're going and buying these types of chips on AliExpress and things like that, they are just pulling them from other motherboards, so I don't really know if it's going to be good or not. I don't have a big chip holder for this. I mean, I guess I have it on my little preheater thing. My preheater thing could actually hold it, I guess. Let's see. It has alarms. But all my other chip holders are going to be tiny like this. So this one doesn't really. Maybe I can hold it. Oh yeah, I guess I can. That's funny. I never use this side of this chip holder. I'll just hold it right there. There we go. Thank you very much. Thank you very much. Right there. There we go. Much better. Yeah, I wasn't burning my finger or anything. You guys are so smart. So Nanofix showed how to do it with just, you don't use a soldering iron, just use a hot air, is that what you're saying? Showed you how to remove flux with iron, just hot air. Or are you talking about just flux? Nanofix definitely has a lot of good tricks. I like this channel a lot. Be careful, don't rip a pad. Alright. How's that brand new CPU looking? Brand new. Absolutely brand new. Okay. Did we miss a spot? We're good. Out of box. Yep. Come on. Stuff gets gummy though. This flux is gummy. Maybe I'll preheat it. Heat it up just a little bit. Douse the whole chip in IPA? There you go. The whole chip's covered in 99%. 99.9999999%. I think it needs to be hot. Okay. There's a couple snaggers here at the field, so I'm going to go back over it. The solder way. Right in this area. Couple snaggers. I'm going to heat this up a little bit, get rid of some of this IPA that's on here. Looks like a little mouse turd right there. That's funny. How did a mouse turd get on here? Doesn't that look like a mouse poop? That's funny. It's fun. Okay. Alright, we're done. So now we're ready to reball this thing. We're going to be ballless today. Let's get our reball on. And we did determine that we can actually reball this one, right? With that stencil. I'm pretty sure. But look at this mess. I feel like I'm making a mess and I hate it. There's too much stuff in my way. Get out of here, get out of here, get out of here. Get out of here. We're going to need that in a second. It's dirty. Be careful not to bridge. You know, we don't want to bridge anything. All right, so the next question is, so I'm going to try to reball this chip. Am I going to be able to reball it in the first try? First go? I've never used this reballing jig before, ever. And I'm pretty sure NanoFix, is NanoFix here? I know we were talking about him. I don't know if he jumped on or not. But I know that he was the one that had this jig. Well, this is not balls, apparently. This is, we're going to be using solder paste. So, that's what's even crazier. We're using solder paste. So let me show you the jig. What I do with it. Okay. All right, so we're going to be using this jig here. Let's see if the stencil lines up. Yeah, paste is very hard, I know. But this jig is supposed to be pretty cool because it has these really heavy-duty neodymium magnets. It holds this plate down really tight. And so we'll be able to just lift it right back off. So we'll be able to put the chip in here like this. It lines up tight, it's flush already. And then we just set this down. And supposedly, it will give us the perfect lineup. Look at that. It's like really tight. And then we'll just be able to lift it off. And it's applying the right pressure. Hey, we broke 1,000. So we have 1,000 live viewers right now on YouTube for the first time. And I think we've hit 970 multiple times or things like that. But this is the first time we hit 1,000. All right, so we have the CPU pulled off. Look, it actually fits in the stencil perfectly. Boom, and we got some, Gritty got us some bits. One bit, 2 bit, red bit, blue bit. This actually looks perfect. This stencil looks like, come on people. There we go. Is that a better view? This stencil actually looks perfect here. You can see that it's lining up, all the pads are lining up properly. And then, let me take this off of here and show you what we're working with. So, the way this works is the chip fits in here, it's perfectly flush to the surface. Perfect, right? And then we have this base that it goes into, and when you set this on top, well, no, and then I set this plate on top of that, and it's just kind of loosely sitting in here, but it does line up perfectly, and then I put it on top of this base with neodymium magnets, and it holds it on perfectly tight. So we should be able to actually wipe on our thermal paste. Whoa, we got some bits coming in hot. Thank you so much for the bits. And my hype train is on its way. We're raw dogging this CPU replacement. So it comes with these little wipey swipers here. And the reason why is because these are non-ferrule metal. Because if you tried to use any type of metal on here, it would, suction to it, so you can't use a regular wipe tool. So we're going to put some thermal paste or solder paste on here, wipe it into the cracks at all different angles, and I'm assuming that we'll lift this thing back off. This is kind of what I'm assuming. I don't really know, but that I'll wipe the solder paste in here. This is the plane at least. So like that. We're going to lift this off of here, and then we're going to take this cover off, and then we'll be able to pop this out like that. And then we'll transplant it over to our preheater. We're going to preheat this, then we'll hit it with hot air, and then all the balls will be perfect. The first try. David. So that's the plan. Is everyone on board with that? Does everyone concur? Add heat before lifting. You think so? All right. So Dead Pixel says to add heat before lifting. So if we're using that premise, then we'll have our chip on here, put this plate on here. This might be a hot stencil. We'll just stencil it. Ah. This may be a direct heat stencil. I didn't even think about that. Yeah, you're right. You're right, because it's not a, we're not using balls. Okay, I gotta get that out of there. Okay, so what we're gonna be doing is we're gonna wipe it in here, we're gonna do direct heat on here, and then we should be able to take it off. I've just been doing balls lately, so yeah, you take the plate off and you do balls. Super chat, $2, man. Thank you. Yeah, this is successful. It's been a game changer, man. But I'm never gonna do this as a service. I'm not gonna do it. All right. So one last thing. We just want to make sure we have this cleaned up. So I'm gonna wipe this down one more time, and then we're gonna add some flux to it. And we don't need much flux, right? And I bet my solder paste is all runny still. Every time I try to use my solder paste, it's all runny. All right. So what flux should I use on this? No flux? Or should I just use solder paste that has the flux in it? I feel like I need something. No flux. Premise says no flux. We got a new member of JFix. Another, I guess you're reselling, huh? Thanks, man. Okay. So we got flux, we got no flux. Now if we did flux, you just do it really light. But we're not doing the solder balls again. I need to get that out of my brain. Because we don't need to give it the stick. The solder paste has a bunch of flux in it, so that's kind of where we're going to have to think about. And again, this stuff is so wet. So wet. I got a super chat, $20, amazing stream. Well, thank you. I'm amazed. I will be more amazed if this actually works. So I'm going to take some of the solder paste out of here, and I believe, I just want to make sure it's dry enough. We're going to do prime sub. Electro Rep, welcome aboard. So we need to see if we can get this stuff dry enough. Actually, it looks pretty dry. What do you think? You think that's dry enough? Looks pretty good. We don't want it running. The last thing we want. I'm happy with that. Looks pretty good. Moist. We want it moist. Literally dry to the max. So you want it more dry than that even? Because you don't want it to run at all? I just don't want it. I mean, it doesn't look super runny. Thin layer of flux will add, will make the solder flow. Well, we may have to do this multiple times, but let's at least try to see if we can get it on the first try. So again, we have the chip lined up here. We're doing no flux. That's what our plan was. We're going to set our little plate on here. And that just kind of lines up right. And then now we'll put that plate over our magnet holder. So now the magnet is holding this down super tight. Okay? And we're not using balls. No balls. Let's see if we'll introduce our second camera here. Okay. Alright, here we go. Trying to wipe some of the stuff in here. This actually seems not too bad. I've seen it be wetter in the past. This is the smallest little spatula. My hands can't even use it. Come on. Try not to get too big of a mess here. I really like that I don't have to hold it down. Whenever I'm doing the other stencils, I have to hold it down to this magnet, manually holding it tight. We're gonna need some more. I need moss. We got a new member, Ron. There's a new member. Welcome to the coolest fans. Well, we'll see. This is the coolest thing ever. We will see. I think I probably should do another layer in there. Can't trust that all these are good already, right? So this CPU has a bunch of solder here. I'm just trying to pick up any remnants, and then we're going to wipe it down. We don't want to have it overflowing out of these, and we're going to try to keep this up slowly. Looks fine. Perfect application, okay? So everyone concurs. You have to say I concur if it's good. And I'm going to wipe this down and try to get some of this extra stuff out of here. Yeah, let me get the extra stuff off the top. We don't want any extra stuff on top. We concur! So I'm going to try to get as much off the top as possible, but I don't want to get down into the holes. So looking pretty good. Okay. And now I got some debris in here. Hopefully that's not going to mess with anything. Okay, we're good? Yeah, I'm doing it dry. Dry wipe. Okay, looks good. Here we go. So we're gonna go. What? 200. I'm not doing it on a heating plate though, so I'm trying to think of like what heat to do. I'm gonna do 250 with like 30% air. I'm gonna put a bigger nozzle on it. Check the whole spill. Okay, we can check the whole spill before we do this. That's why I wanted to like do it multiple times. I'm gonna zoom in real good. So some of them are, they're all a little bit low now because I wiped it. So is that gonna be too low? I think it looks good. But I've never done this before. I mean, I've done it on regular chips. That looks good to me. Does everyone look good? 250, 5%. I don't know. Mine. I don't know how hard yours blows. I mean, I do less air. So I'm at 2%. Okay, so we'll go down. We'll start at like 20%. You said 5%. I don't know. 10%? 15%. Okay, looks good. Everyone concurs. Okay, moment of truth, people. Actually, moment of truth will be when we put this on the other board. All right, so I'm at 250 with, what does it say, 15% air? I don't know, do we want this up there or this side here? I'll keep it on the side here. Okay, here we go. So I'm just gonna heat the side first. So I'm just gonna try to start heating the plate up, but we don't want to heat the actual die too fast. So we got 350 of 25% air. We got 250 of 5% air. We got 1,124 people that are tuning in, which is kind of nice. Only 58 people are on Twitch. Some of you YouTubers should go over to Twitch. That way we can get some more, get that view count up. Trying to get that average up higher. Because I've only been averaging like 60 or 70 on Twitch, but you need to be up to 75 to become a partner or whatever it is. Pad under it, pad under it, 400. So now we got 400 with 35%. So I usually, this is 255 with 15%. I'm heating this edge, and I usually will go, I think I usually do 300 at like 25% air. Yeah, so this doesn't, since nothing's happening, I have a bigger tip on here too, so the air pressure is going to be a little different. See how nothing's happening on this corner? Or we're waiting for something to happen here in this corner. Nothing's happening. All right, so we're going to go up to 300 now, and I'm going to be at 30% air, 300 at 30% air, so we just basically went at 50 degrees. And again, I'm heating the side until we start seeing a little bit of balls start heating up there, or start melting. And we do have a bunch of people coming in on Twitch. I appreciate you moving on over there or doing that. And we got a new Prime sub. Thank you. Fun jab. Just waiting for this corner to go. Waiting for that corner. Move the gun around the hot plate. I generally start in one corner, but yeah, I guess I could do this. I generally don't do it like that, but this is a big chip. It's different than I normally do. Need more air. Yeah, I mean, that's where we're starting low. You do 380 for a further distance. So if I heat this whole plate, the idea is to bring the plate up to temperature, right? So now if I heat this corner, so I might need to go 350 or more air. So 30% air, so if I go up to, so now we're at 50%, well 50% seems like too much air pressure. I don't want too much air pressure because I don't want to blow the balls. So we'll go up to like 350. So we're at 350 air now at 35% air pressure. 350. That's like a preheater for the chip is so much easier. This is the, and then this whole die is probably taking some of the heat. I feel like it's about to start. It's about to start. Yeah, we got a lot of people going over to Twitch. I appreciate it. Hey, look, there it goes. Watch it. It's going. It's going. Oh, it's so satisfying. Look how satisfying that is. Uh-oh. Did you see what just happened, guys? I'm going to move away. This thing lifted up. It just warped. It just worked. I'm trying to apply some pressure in the middle. It just freaking warped. Are you kidding me? Oh, it's magnetic. I can't do it with this. Oh my gosh. What is going on? So this whole area lifted up just now. Oh my gosh. What the what? I thought the whole purpose of this was that it's supposed to be a direct heat stencil. Maybe I'm doing it too hot? I mean, we're just going to have to kind of keep going with it. Yes, it's heating, it's lifting again. I can't use that screwdriver. It's lifting again. Some of those balls are not even touching anymore. This whole area is lifted off. Setting back down. Or maybe we'll just go back to this. This is not magnetic. And this is burning my hand like you've never believed. You know what? I think's happening? A design flaw. Oh my gosh. Okay. What? I'm gonna try to move this. So this whole area lifted up out of here. I mean, it looks like we're doing something correct, but you can tell this is all effed up. You see that? We're all warped and lifted here. All those falls, or this whole thing's ruined. I want to keep going with it because I want to mess with see if we can get this side to stay down, but I don't get it. I wish Nanopix was there. Someone go get him. Because he's used this before. But he always uses on smaller ones. Who has used this stencil before? I can't even believe this. I thought this was a direct heat. I thought that was the point of this. Does it say direct heat on here? Was it just too hot? There's no reason for this. I'm thinking that like the magnets came unmagnetized too. Heat pad works. So if I put it on a heat plate, then heat the whole thing. Try using a clamp. Try heating faster. Heating the whole plate. So heating the whole, you're saying the entire metal plate on top, or the entire, holder? So like heating the bottom here, or we're talking about just like trying to get this whole area cooled up, like using no nozzle on the end or something like that? I'm going to have to start over again, yes, that's what we're going to do. Heat evenly across the stencil so that it's, okay, so maybe use no nozzle on top, so I'm not just heating one little area. Not enough heat. It happens all the time. Not the entire plate, it will warp it. Reflow the balls faster. Okay, well let's experiment with what we have here at least. And then we'll go back to the drawing board. You're doing it too slow. Okay, alright, so we're going to do it faster. That means I need more heat then. So now I'm at 400 degrees C at 42% air. I'm going to start a little higher just to try to get the whole plate heated up. Now we're just experimenting with the rest of this. I know that it's ruined, but I want to see if this thing doesn't lift up again. Still lifted up. That whole area just lifted up as well. That whole side. Look at that. You see it lifting? I'm going to zoom in for you. What the F? Are you kidding me? Alright, we're zoomed in. Watch this. I mean, I don't know how else I can do it better. Are you freaking kidding me? Oh, sorry, turn it right on. Put something on it so it doesn't lift again. Well, I did that a second ago with my... Yeah, look at that. You see it lifting? You see that? Did you see that? It is ridiculous. The reason is there's no flux. Oh no. Okay, I'm going to hold down with the back of this. We're holding down, applying pressure. I'm going to let it cool. Just so I can move my screwdriver here, or my pliers. Applying pressure. We've got some messed up balls there. So applying pressure seems to be working. All right, so let me get really mad at this for a second. Or someone tell me like, okay, we're gonna sit down and take a break for a second because this is. It doesn't make sense. I need to go. I need to be aggressive. Be aggressive. Tea time. That's right. It's tea time. We're gonna have some nice ice cold coffee. Yeah, a lot of people coming over to Twitch. Well. All right. So if you've given me suggestions, go ahead and post them again because now I can focus. So we have something saying that the flux doesn't have, the solder paste doesn't have a flux in it. Somebody's saying that. Clean it and reball it again. That's what we will be doing because I'm not going to give up that easy. Put a thin layer of flux in a circular pattern, also heat the underside. No temp change, no air change. Metal is expected to expand. Well, the thing is, this thing is like lifting. It looks to me, it's like lifting like it's not a direct heat sensor. Please don't give advice. Please don't give advice on this stuff. That's true. So if you, excuse me, if you haven't ever done this type of stenciling, not this exact stencil, but like, then you probably should use something. Yes. You finally made the stream from Uruguay. Welcome aboard. Yeah, this is a crazy one too. Take a breath. I got this. You guys are so motivated. I'm motivated. Okay, premise. What are you saying here? The nature of the stencil, not to apply downward pressure. And it's funny because you know how magnets lose their power, I guess, or their magnetism, the heat. So it's kind of a weird design. The idea is there. The idea is solid. Because that's why I was thinking, like, what if I can just dump balls? That'd be cool. I don't know if I can because it's going to leak everywhere. I was lifting because it's going to left or right. These stencils fits in here super tight. If you're using solder paste, then you don't need solder paste. Doesn't make sense. Kenneth Palmer is the only one who does this daily. Dave and Brandon, who are you talking about? Who does this daily? I missed that. I didn't even know who does this daily. You can pin his comment. Can't you? Are you sure the stencil has to be left on while you melt solder? That's. I thought. I don't know if someone can look up this thing. The manufacturer is Orange Box. So if you want to look that up and tell me how to use this thing. Wait, it has a QR code for the phone number. Maybe we should call technical support. Quick, someone call technical support. We can hook up it. There you go. I can't believe this is it my bad solder paste? No, the thing is the steel keeps expanding. Okay. Let me take this thing off of here. Because the magnets get really, really hot when you're doing this. Like, it almost seems like... What if we... Okay. Stay with me here. What if we put this on here, use the solder paste, okay, because the magnets are holding it down. Then we take this off. And then we put this on our heater. like this, if I can get the fit, and then we do it. Does that sound better? The underside looks like that, so it's not like it's getting a direct heat to it. There's like a space, but I don't know. Does that seem like it might help? We got it. I concur. No, we got a no. Good idea, I guess. Less heat on top. It won't work. Okay. So if it won't work, what will work? We didn't use a preheater on this because I wasn't heating this whole thing. Should I be heating this whole thing is the question. This thing has magnets in it, and the magnets start releasing. And then the actual thing works, the metal works. Don't leave the stencil on after you apply the thermal paste. So try to lift the stencil off and just leave the paste in place. I don't think that's going to work. Maybe it will, maybe it won't. It will work with, it will be the preheater. Remove stencil and apply the heat. The people who are suggesting remove the stencil and apply the heat, you've done this from experience or you're doing this because it seems logical? Neodymiums are at even lower temp. Yeah, neodymium will loses actual magnetism really easily. Oh my god, chat, no. I like that comment. I like that comment. Oh my god, chat, no! Don't tell him to do that. The whole thing needs a redesign. The paste thing. I mean, maybe I just apply pressure in the middle while I'm doing this. I don't know. Okay. Well, I need somebody to tell me. All right, let's see if we can just chip out of here. So we have a bunch of solder balls that are all messed up here. Okay. We apply the paste, we take off the stencil, and then heat it in the oven works fine. Alright, so maybe I should try this just for science. So I will put the chip in here, put the stencil on, wipe on the stuff, try to take the stencil off, and see if we leave all our solder balls. Do I have 40 balls? Yes, I have balls. I have a bunch of these balls. Some 4-5s, some 2s, some 6s. There's a 5. There's a 3. There's a 7-6. And 2 5s. So I don't have. I have 4 5s. It's the only one that I see. But I don't know how I'm supposed to spread them in there. This one doesn't even tell you what size it is. Do you have a magnetic base? This is a magnetic base. That's why it's losing magnetism. So size 70 by 70, 3.0. So these are 3.0 balls. Or 0.3. So I really don't know if I can actually roll the balls in there without them spilling them everywhere. But we could probably try that. I don't know. You guys are saying so much stuff, my brain can't. I just need someone to filter it for me and tell me the right things. So, one of you mods, put something on the. Ring my bell and tell me what to do. I'm gonna just take this chip off of this stuff right now. This is just too much. My brain can't handle this. My little brain cannot handle this. Thank you for this super chat. Use tweezers and press around the sides. Okay, so we can try doing that. So these tweezers here will work. You must apply pressure on the steel while doing it. Okay, so that's what we'll do. Should we not try taking off the stencil? Should we just skip that? We should try just doing applying. These tweezers work okay. They are still magnetic. I can feel it, but it's not too bad. If I use these other tweezers, oh, these actually work pretty well too. So I can use these. Alright, what I was trying to show you is this. This is the magnet. And I don't want to get sucked on it really hardcore like a freaking thing. Use tweezers and press around the sides. Okay, so that sounds like the consensus of what we're going to do. So let me get this chip taken back off of here. Thank you so much, everyone. This is all for science. Or not science, because no one needs to be trying this at home, by the way. I got a couple balls that are transferring through. I just need to get off here. We got another one. Use tweezers all around the sides. Listen to Sweden's Electronics. Sweden's Electronics, okay? I will be listening to him. First, Sweden's Electronics. Let's see if I can. I think I can pull up all of those chats here. Okay. Alright, so I'm going to listen to you, Sweden's Electronics. So this is what he says, and I got all of his chats pulled up here. 440C, 70%, no nozzle, heat evenly across the entire stencil. Okay, so that's what he said multiple times. So are we? That's what we should do, right? Because you've done this before. 440. No nozzle. Darn thing. Then you release this off here without ripping a pad. I got a couple balls that have gone through. Okay. Couple balls going through. Thanks for the bits. Gosh, this is killing me. These balls are so messed up in here. And I can't get my soldering iron to get in there. That's right, so I'm going to keep this whole thing off of this. That's something I was really looking forward to. Sounds like a casino. Nathan, your mods don't know how to use the bell message. Okay, I think most of them do, but it's just exclamation point bell, space, and then whatever message it is. Well, I have to say some of these balls look okay on this side, which is funny. But we're going to clean all this stuff off of here. And if you are a mod and it's not coming up, then if the bell message doesn't work, then let me know and I'll have to add you to that special list. What's up there, Dario? That's my little sister in the chat. She just jumped in. He does this every day. Okay. All right. Well, then we will be listening to him. Or them. I want to follow their advice. Buy the book here. works fine for premise. That's right. You have to heat the stencil evenly in a circular pattern. Okay. Alright, well, we are listening to him for sure. Get 0.4 balls to do GPU repair. I'm not doing any of this stuff for real business. I'm telling you right now, this is not worth it. This is just for entertainment purposes only. We've already done this before. This is nice. Cleaning off the CPU. Getting all these balls off of here. I thought it was going to be too easy to get it done on the first try. I don't have it in my chip holder, I realize. I'm like dealing with that right now. Almost got it all cleaned off. I'm just trying to get these back down to flat, so we can raw dog this all over again. Okay. Oh my gosh. Yeah, this is a 7th gen something. So is it a 7855? I don't think it is. I believe. Great balls at 5. I don't know if this is gonna work, but I'm gonna listen to the person that knows how to do this. We're just trying to get this cleaned all the way back off, so when we go to put some new solder paste on here, we'll be able to get it to stick properly. Right here. This is just isopropyl alcohol in this one. Okay, almost done. Clean that off. And we're going to, so we're going to use no nozzle. We're going to use 440. Is that what you said? 440 at, I already forgot. 440 at 60% here. Say it again. 440 at, darn it, I can't find it now. I know you posted a bunch of times. 440, 60%. 70%. Okay. Because with no nozzle, you actually need more air pressure. Yeah, 440, 70. Okay. Alright, so here's how it goes. We're doing no flux on here. Walk me through this. Alright. So we'll put the chip on here. And we're putting no flux on, right? Oh yes, okay, good idea. That's what I'm gonna do. I'm gonna add him to the bell message. Give me a second. I gotta add permissions here. Actions. Commands. There we go. Bell message. Permissions, users. Okay. Alright, so you should have permission to do that now. So you can send messages, Sweden's Electronics, so you just type in exclamation point bell, space, and then whatever you want to set. And then it pops up on the screen. If it's too long, it cuts off the screen, so don't do it too far. But should I be adding flux to this? Hey, it's working. Hello, Mom. How you doing? No flux. Okay. And so, let me make sure the stencil's all cleared off. Actually, the back part of the stencil. Yeah, we're gonna have to clean this out too. It's like starting all over again. Alright, I'm just going to try to clear out. There are a couple solder balls stuck in this. We want to make sure that this is completely clear when we're trying to get the solder paste down in there. And the solder works, hopefully will pick it all up. Okay. Hate when it gets all dirty like that. This thing has like texture to it, which is crazy. Live stream Sundays, toxic work culture. What? Alright, I think I got all the sticky off of here. Now I'm filled with this story stuff. It's like everything's so sticky with this flux. And it's irritating me. I don't want to have any of the furry stuff in here. Just blow it. Yeah. Okay. Let's go. Yeah, I just put a bunch of isopropyl on it here. Alright, that's much better. Still feels sticky. Hopefully that's clean enough. Another clean enough? With all the holes clear. It's like my hands are completely sticky. I don't think I've ever had this much trouble with flux. You highly recommend recommend a very thin layer of flux? Well, right now I'm going to kind of go with the person who's been doing this every single day. I know that I usually put a layer of flux when I'm doing balls, but when I'm doing solder paste, I generally don't. So it really depends. Ah, this is so sticky. Ultrasonic cleaner. Yeah, I have it warm. Microfiber cloth. Like all I have right now is these chem pads, which they don't seem to be microfiber. I think we're good. I think we're good. And blow it off over top. Yeah, see, it's like so sticky that everything kind of keeps getting on here. Every time I douse it, this is 99%. 99%. Ultrasonic clear. Okay, let me blow this off one more time. Alright, we're good. I think this is good enough, right? I don't know how picky we need to be with this. Looks good. Are all the holes clear enough? Look at that hole. I don't know. I got stuck in this. Alright, does that look good enough? To proceed? Alright, so we'll put this on here like this. So, will I need to be able to hold this down? Because I can already see it's warped at this point. It used to not be. But we put it on the magnet. That should hold it down flat. Now it's flat. Right? So is that looking good? Yeah, it's flush. I'm going to blow it one more time just to see if I can get rid of any extra fuzzes that are around here. Okay. Next on the agenda. Solder paste? Yeah, we need you to use the bell, please. Swindon. Use that bell. You're in charge. He's the chief. He's the chief operator. Apply the paste. Go. All right. So we'll do what we did before. Swindon, do you use the same jig? So you're familiar with the way that the magnet works and everything? Okay, perfect. Well, then you know exactly what we're doing here. Okay, so it needs to be. My paste should be drier than this. So I just leave it at top open for days and weeks. This is definitely drier than I usually have had it in the past. I've had it more runny than this even. So I know that you want drier the better. All right, and then so what I did before is I wiped it off afterwards. Use hot air on the tub and stir it around. Really? To try to dry out the flux out of this? Huh. Okay, that's interesting. Now, I wiped it off before with one of these little cubes and then a Kim pad. Should I do that? The same way? Just want to try to get the rest of the stuff off here. With thousands of people watching me fail. Okay, is that going to work? Is that good? Okay. Are we ready for air? So we're doing no nozzle. And a raw dog it. We're doing let's see if we can get this over here. $470. Wait, 440. I'm getting all the numbers mixed up, which is funny. 440. 440, 70%. Okay, and fast movement. So I'm going to be doing it. I can't do it over with the microscope if I'm doing it like this. So just kind of doing this over the whole thing in a circle. Is that what we're thinking? I'll see if I can get the microscope in there or some sort of view that we can see it happening. But so if I just kind of do it in that motion, it should be good. All these people want to do the bell command. Yes, wider spread. Okay. Hold the stencil down. Oh, okay. So if I hold the stencil down right in the middle, would the back of this would work? Or should I be trying to, well, if I use just the, I don't want to mess up those tweezers. Don't hold it. Don't hold it. Okay. We got hold it down, we got don't hold it down. But I'm listening to Swindon here because he uses the exact same process every day. Okay, there we go. So I'm going to do a circular pattern like this, wider, fast, high heat, and I'll see. Maybe we can get the. Let's see. Maybe a split view. Oh yeah, that's a good view. Oh, I like that. That's a good view, huh? Okay. So I'm going to try to do this. Okay. All right, we're going in. Put some air on. Make sure this is focused good enough. I don't know how close I need to be, but the suspense. Yeah, so people who don't have the bell, you can actually do a super chat, and then I will see that message. So you're welcome to do that anytime you want. The mods are the only ones who can do the bell message. Come on, I'm actually nervous. My heart is starting to beat really fast. Keep the whole stencil. Why not doing it the whole stencil? Oh, the bell doesn't work on this scene. Yes, you're right. I need to add it. Thank you. Hard to see from this angle. So, like, how close should I be is the question. I feel like it's going. It's going. I don't know if the stencil's lifting up or not, but... It looks like it lifted up. What's up in the middle there? Okay, I think we're done, right? Oh, I got all the edges. Can't tell what's going on here. I should have held it. Well, I have no idea if this works. See some crazy stuff going on here. What the what? Oh, those look good. Those look good. I don't... Did we not fill up the holes all the way, or did the stencil lift up? I mean, look at this. How is that even possible? I'm so sad. Too much air and the balls jump out. Possibly. Just lift it. Here we go. Okay. Like, I'm scared to try to get it off with that ball sticking there, because that's probably stuck to the one of the pads, so I'm not going to be able to get it off. That side's coming off. That side's coming off, but I'm scared about these. Probably should wick those things up and just try to fix these pads that are messed up. I don't know what to do at this point. Raw dog, screw the scooch. When you're applying the face, I noticed there was pockets of air. Yeah, I mean, it definitely could have been. I don't know. That's, you know, it's just like, told the press to hold the stencil. Dose of heat. I think Swindon knows what he's talking about. Yeah, I think I probably didn't apply the paste properly, if something's wrong. I'm going to try to wick up those balls right there, and then see if I can get the stencil taken off. You have a super chat? Sorry, I got distracted. That's why I use tweezers around the sides. I mean, this thing's way too big for tweezers around the sides, so I don't know how I can do this maybe around the sides, and then move to that side, but it's like, because we're heating the entire stencil, it's really hard. You have to go over the paste twice. That's probably, yeah. I don't know why I did not. I'm just going to pick these gold balls up here. Is everyone sad? I'm sad. Alright, are we going to get this thing out of here? That is the question. Like, that ball's so big right there too. That ball's so big. That ball's so big. Like, all of these are sticking through here. That one's really big. Can you preheat the stencil? I mean, that's what I'm kind of doing, but... Alright, I'm going to have to just take this thing off like we did before, because I don't know how else I'm going to do it without ripping a pad. I don't want to rip a pad. I think we're getting closer. Now, I'm going to tell you right now, if I was doing this on my own, I'd be going through the exact same process. It usually takes a few iterations to kind of get that figured out, and it does help a lot that I do have experienced people in here, especially people who have used this exact same setup. So I do appreciate that. So I think we were on the right track with this. I think that I just did not apply the thermal paste properly, is what I'm thinking. And you believe it's the thermal paste is probably not, it needs to be drier. Okay. So, is there a quick way for me to dry it? You're saying to heat up the actual vessel. I don't know if that will work instantaneously. Whenever you're saying too much air, like I have no nozzle in here, 70% air on this is not that much whenever you have no nozzle. I need drier solder paste. Should poke Lewis. Yeah, I should go down and just borrow his reballing machine. He's only like a few minutes from here. Solder powder. If I just had solder balls, I could drop it in holes and be so much easier. So Paul Daniels dries it with hot air in a towel. Thanks for the prime sub, Tool Man. Even though I'm epically failing here. Oh, come on. Come on. Okay. Alright. It's completely destroyed. Alright, we get to stop for a moment. Stop what you're doing, because I'm about to ruin the image of the style that you're used to. Okay. Alright, give me a second here. We're going to hang for a minute. And then we'll come back to this crap. I wish I had more coffee. Alright, so I think hey, thanks for the super chat. Yeah, I think I need to work on our solder paste. But I think we're on the right track. So when I was preheating this is still hot here. I want to see if we can get a better angle on. So let's see. How can we? So I was basically. I was starting on this edge going out. I was staying on the outer edges is what my goal was when I was doing that. So is that the proper way, right? I didn't even need to go in the middle at all. And just trying to stay on the outer edges? Or do I need to make sure that I'm kind of doing an X or what? I don't really. Or do I need to stay further away? Because I was probably getting about that far off of it. So do I need to, is the idea of staying further away? We need to save these solder balls. We got a new member, Johnny. Johnny is part of the coolest fan club. You never know how deep the rabbit hole goes. That's right. Yeah, down the laptop repair rabbit hole. I want to. Yeah, I can tell you all about this repair I did 2 days ago. That I ended up taking off 15 chips, and I kept finding blown up components. It was all like on the USB charge circuit, but every chip I took off that was exploded and burnt, there was still a short on the board, and I kept taking chips off and kept taking chips off. It was just like, I had to give it finally. Put pressure on the middle. So we have, like, Swindon doesn't put pressure on the middle. He just heats the whole thing so it doesn't warp, which sounds logical to me too. Putting pressure on the middle sounds logical too. Now, I don't think it will hurt to put pressure on the middle. But if I'm not heating evenly, then it's going to be moot anyway, because what I did notice when I was applying pressure before in the middle, I applied pressure here, and I was kind of heating like that, it started lifting on the outsides, because I wasn't getting enough heat on the outside. So the whole thing needs to be heated, and then we won't worry about it actually doing anything wrong. So, it's nerve-wracking. I mean, we knew what we were getting into because I actually was pretty impressed on how easy it was to take the CPU off. And then I guess if you were able to just source one of these and buy one that was already ready to go, then you'd be buying one that's already balled, and then you'd be able to just drop it on there. So, I think this is a pretty good design. It's just you have to have some sort of constant heating source if we have something that will heat very far away. We have another new member from the Tools Plans Club. Thank you. Welcome. Use solder ball. No need to hold it down. If I use the solder balls, then I can just move it away. But I have one of these jigs that I use for doing that. But I don't have a stencil that will fit. Because these take 90 by 90s. This is a 70 by 70 stencil. We're fully invested now. Yes, I'm just taking a break for a minute. We will continue. What time is it? 11:30? Do you think this isn't a direct heat stencil? I'm starting to think that, but since Swindon uses these. Thanks, Andy. Yes, thank you, Swindon. Thank you so much. Andy. Thank you, Andy. So he uses this exact one. Okay. He uses this exact process. He live streams every day. Okay, well I need to follow him. He live streams on YouTube? Well, I definitely need to follow him and check it out. I found this flux 559 no clean soldering flux on Amazon. Well, it may be real stuff, it may not. Okay, I'm gonna get back to this. He does console repair, not laptops often. Maybe that's why I don't play console games, so maybe that's why I haven't stumbled upon it. I'm not in the console world. Alright, I'm gonna start cleaning this stuff off, and then we'll give it another go. I think we can do it. Third time's a charm. $16.59 seems like a cheap price for 559. Is it a big giant file, or is it these little tiny ones? Alright, so we need to clean the stencil back off, get all these balls out of here. Remember how sticky it was last time? Yeah, I want to get some of that solder braid that has the flux already in it. The stencil may be poor quality, too thin, incidentally. Faulty. Oh, really? The faulty Alienware M15R7 came back to life after reballing the processor on the processor. The M15R7, those things are notorious for having bad CPUs, and so if that's the solution for it, but you just reballed it and fixed it. So the CPU wasn't faulty, it was just the actual balls underneath. That might be something to think about. Now I don't know where to go after this, so if we do a third time and we're not able to do it, I don't really know what to do because we've already been at this for 2.5 hours, and so I may have to go back to the drawing board. We're trying to come up with another plan, but I didn't think this was going to work anyway, so I guess I'm not that surprised. We got some bits. Thank you for the bits, Kevin. Or Kev H. I never know how to pronounce names. A long process, but we're going to do it. I'll try to do my best to kind of answer some of these questions while we do this so it's not super dry. The most interesting live in episode yet. Alright. Well, I'm glad I can make some interesting content. I figured it would be kind of interesting to see the process of somebody who's has literally thousands and thousands and thousands of hours of soldering struggle. And I just heard, like, whenever I have issues in videos and I leave all the issues in, I want you to see that, you know, it's not always straightforward and easy to fix things. But I was reading some comments and people said their favorite videos are the ones where they see me struggle. Because then they know, it makes them feel better probably, but that's just the way it is. It's not like everyone's not rainbows and unicorns. So, do you agree with that? Yeah, we hit 1,100 viewers on YouTube up for the first time. Very impressed. It's great to see everyone here. You know, we're starting to fall off a little bit because this is the boring part again. Yeah, if I spent tons of hours reballing it, I wouldn't know how to do this. I've reballed plenty of small chips, but not these big ones. So we have to pay attention to things like this. We need to make sure that all the holes are emptied out. Our stencil is perfectly clean. Even if you've experienced people struggling with new tasks, all this, wake up, smell the flux. Alright. It's all sticky again, all over again. You learn when you struggle, right, and you don't learn when you give up. So, a good thing to ask your kids every day is, what did you fail in today? Because then they can know that it's okay to fail because that's how you actually learn how to do something. So you ask them if they failed at, and then they will end up succeeding at some point. Okay. Hot air it, spray it, alcohol, hot air it. Yeah, let's try that. Let me get this sticky off my desk. This is the most sticky desk I've ever experienced in my life. I feel like I have like a mess of towels and Kim pads. Okay. Let's do that. We'll hot air it. You know, like I'm holding my hand out here. I'm just trying to figure out how high up I should be on this because this is actually getting pretty good heat. And so if I stayed back here, I might have more like even heat. I don't know. Because I was getting about that far, and so maybe if I go that far, I don't know. The stencil seems pretty good now. I mean, I could use. Should I do it with water? It's just sticky, so every time I try to wipe it, anything sticks to it, so that's why I'm trying to use anything to touch it. But I'm happy with it. Alright, so that's done. Let's clean this off now. Okay. And now we gotta do the CPU. I guess we can look at some of the balls that might have been okay on it. And those look good. I mean, for the most part, it actually did pretty good. And then we have the areas in the middle. So this is the area where we had some balls sticking through the holes. And it looks like it's slid over or something. I don't know why that one got big. So it's like it stole the ball next to it. All the big balls next to the small balls. So I think it did lift up, like you were saying. So I think I will have to hold it down. I don't think it's going to hurt anything to hold it down the middle. All this area right here is slid when I was trying to get off the stencil. Okay, I gotta get all this stuff back off of here. Just lay tweezers down and hold it. Yeah, I'm gonna use the back of my tweezers on this route this time around. I have to make sure I have it far enough away so I don't burn my painting. But because the heat's spreading a lot. For God's sake, you should use a nozzle, and it must be small one to concentrate the heat. Adam, if you're just joining in, we started with a small nozzle, and because the heat plate is so big, it warps. And so, if you find something aluminum, so my tweezers are half aluminum. So Adam, when we're heating in a concentrated area, which is actually warping the plate, and so we have somebody in the chat who uses this exact stencil every single day, and so we were following his technique, which is no nozzle, for God's sake. If that makes sense, Adam. Or Adam, do you use this exact stencil? Maybe you do. Maybe you use it every single day. If you do, then chime in. Do you read all CPUs? 7th gen CPUs? I'm definitely open for your input. Better have a thin layer of flux. That's what I'm hearing. So we're going to put 2 layers of paste in the holes this time. We're going to hold down the center, and then we're just going to make sure that we concentrate on heating the entire plate at the same time. At the same time. Yeah, we don't want to heat the center. We want to heat the edges, but we want we want the whole thing to be good, really. For God's sakes, that's right. Use a hot air gun. Yeah, I could grab my hot air gun and just raw dog it that way. Since we're raw dogging everything right now. The CPU's not even going to work by the end of all this. So honestly, I like the type of live streams where you see the full process and mistakes. Usually, everyone shows just the results of success. That's exactly what I'm going for, everyone. Exactly. Well said. So the whole point of this is to not have rainbows and unicorns, not show that everything just works. And that's why even my videos, I leave in all those mistakes too. I mean, I still cut it down so it's faster paced, but I do leave in where I'm like fumbling around, fumbling idiot a little bit. We're almost done. We're almost ready for round 3. Just gotta get this nice and clean. Okay. All right. I think we're good. You can do this. Thank you for the motivational support. If I do this, it will be very, very entertaining. If I don't do this, it will be very, very entertaining. You see? It's a win-win. It's a win-win-win. Gotta get this clean. Gotta get it clean. Ah, this flux sucks. I wish I used better flux too. Can't get this off. Heat it again. Win. Whenever I say that, I always think of that Office episode where Michael Scott's trying to explain different scenarios. Win. Alright, the stickiness is everywhere. God. It's like I just want to stick this in a bathtub of isopropyl. Alright. Almost there. How did it work? It's a 7th gen i5, is it really? Oh. Well, that's not even worth saving. No, it's not worth saving. We got a couple. Should I even worry about these, Swindon? Those little, when you have it where it's just a little bit raised up in some spots, I mean, most of it's gone. Should I even worry about it? I generally, I'm not that concerned with it because the solder paste is going to mix with it. And since we, yeah, I'm good. I'm good, mate. Love it. You're the man. Okay. And I guess your name's Andy, is that right? I can call you Andy instead. Okay. So we are going in like this again. Where's my stencil? Someone see it? Here it is. Alright, we're nice and tight. Alright. I see something in this corner hole here. What is it? What are you? I'm going to blow this like I did before. Alright. So again, low probability that we're going to be able to successfully do this, but I feel like we're getting closer. Alright, so we're going to put on our thermal paste, solder paste. Now, I should try this out more, I'm guessing, but I need to make it really dry. And so the technique for really drying it, I mean, I've seen people wipe it on these tin pads, but then I feel like I'm like picking up like stuff, like fuzz when I do that. So, I mean, should I wipe the stuff on my tin pad here and then try to like pick it up to dry it off? A lot more pressure will help. Yes, I can do that. Then we do a couple of coats of it just to make sure we have plenty. You're blowing on the alarm. hopefully the stuff is going to be dry enough. Wipe it on a microfiber towel. I don't have a microfiber towel. All I have is skin pads. So, if you heat the stencil in the jig, you will fail again. So, Mr. Tom, I want you to explain all about that because this. Have you ever used this jig before? When looking at the balls were okay. Small planks will hold down the center. My plan is to do this in the center. Is that okay? Or this? Because I feel like we're going to have to do something. Don't wipe it at the end. You don't wipe the flux. I mean the paste. Because if I take some of this paste here and put it right here, so it's still pretty wet. I'm trying to pick some of it back up. Yeah, it's drier, I guess, but it's still wet. It's not dripping. Yeah, it looks like thermal paste, you're right, that's why I keep calling it that. Should I go with this? We good? I'll just apply some pressure, make sure we're doing good. It's too wet. The last time it seemed drier, or maybe I found a drier pocket. Google said 470. I don't know how much air. Yeah, so that's max heat. So we're at 440. More than brick construction. We're good. I'm just trying to figure out. I mean, I don't want to do this a fourth time. So this is kind of like going to be a deal breaker here. Let's go with balls. We did balls. It would go everywhere. I don't know how we're going to do balls here. What temp is the solder paste? It's 183. I only have two different types of solder paste. And they're both cheap. So I don't reball stuff enough. I think this is the other stuff I have. Some other stuff here. That's not a ball stencil. Yes, it's not a ball stencil. This stuff might be drier. We can take a look at this. Oh, this stuff's hard. Oh my god, it's like a rock. Oh my gosh. Oh, I can't even scoop this stuff out of here. It's so hard. I haven't used this stuff in a while. Is that what I want? Some hard as a rock stuff? I need something longer to scoop it out of here. Remove stencil and hot plates. Okay, so this paste down here is pretty freaking hard. Alright, so here's the other solder paste. What temperature is this? 183. So here's the other paste. It is gooey. Look. It's like really hard at the top, but it's all liquid at the bottom, so that's not good. We got too many people, too many chefs in the kitchen right now. Too many chefs in the kitchen, man. I'm gonna do the same thing that Andy said did the last time. We're just gonna apply pressure in the middle, and then I'm gonna just try to do the best I can with applying this solder paste. Hopefully I can get it dry enough. So that's what we're going to have to do. Here we go. Remove stencil before heating. Everyone wants me to remove the stencil before heating. This is too much. I'm going to apply more pressure to make sure these holes are filled. Don't remove the stencil. I'm not going to, I promise. I promise I won't remove the stencil. Because I know for a fact that somebody uses this exact setup and it works for them. So I want to do exactly what they're doing in order to get it to work. Now I need to somehow get my paste not so pasty. That would be the big solution. This seems runnier than it was before the first time. I don't know if I just found a different pocket. I'm trying to pull it from the top so it's the drier area and not the bottom where it's all kind of runny. Yeah, this is way too runny before. Try to pack it in there. I think it's just too wet now. Yeah, I'm going to put some good pressure on the center when I heat it. Alright, let's look over this real quick before we heat it up. That one's a little low. Has something in it. Yeah, I didn't wipe it with the towel. I just used my finger this time. I'm going to add a little bit more on that one edge there. This seems a little drier actually. This batch I just got. I don't know what's up with these spatulas. Do they only go one direction? Okay. Use L-shaped tweezers. See if I have my L-shaped tweezers. Alright, does that look good now? It looks good to me. I don't know if I need to worry about that little chunk, whatever's in there. Okay. Looking good to me. Alright, so as for using the flat tweezers, see if I can find them. dig in my drawer over here. We'll see. Trying to find a pair of those. I know I have a pair at home, and the other pair that I was using for something else, and I can't find it. Let's see if they're up here. Okay, got my pair of tweezers that are the ones that kind of have the little flat bottoms on them. Oh, they're magnetic. Oh my god. Okay, well that didn't. That's the problem with some of these. I can't use them. So I just mess up mine. Balls. Looks okay. Or maybe I want to be magnetic. I don't know. The whole team concurs. So my plan was just to use the back of a pair of these aluminum tweezers, like that, in this orientation, and just hold it right there. Do I have a metal ruler? Big magnet in the middle would be nice. Another magnet? I mean, I have more magnets, but I think what's happening is it's losing its magnetic properties because it's heating so much. Need more people from YouTube to come to Twitch. Oh yeah, well, we only have 83 people on Twitch right now. 82. Alright, I think we're good like this, right? So we're going to come back over here. Let me get my dual camera set up again. You want me to move the chat over there so we have the chat at the same time? And, oh, we need to move our message. Bell message. Copy. And then we're going to split camera. Paste. Okay, try a bell message. I'm going to see if it shows up there. Should come up. What am I doing? I'm reballing the CPU. I pulled it off of another motherboard. The test is working. What else did we need in this view? Did we want the chat on this show? Chat, where are you at? There we go. It's going to be on top of that though. That's all we can do. Okay. So we have our chat, we have our messages. We're going to be trying to get this heated properly. I'm going to move this microscope kind of out of my way. We got a new Prime Twitch member. Oh yeah, I don't have any of those alerts over here. Alright, so we're still at 440, 70% air. Now as for the distance-wise, we go to widescreen. I'm going to turn the heat back off. So Andy, take a look at this. How high do you want this? I was doing about like right here before. About that height. But I could go higher. So I was doing about right there. Go back to that split view. I don't know if it's going to show better like this. Why is it not focusing? Where you had it before. Okay, so we're just going to do that and apply pressure. And I'm going for it. Okay, third time's a charm. Use small nozzles. You got it wrong, buddy, because this is a big stencil, so you can't do it on a small nozzle. Okay, so I'm going to hold down the center. Hold down the center. I need air extra, or else I'm gonna die. This is the way that works for me. This is the way that it shall work for me. I'm trying to get my hand out of the way here so I don't burn my hand. Okay, there we go. So try to heat the edges more than the middle, right? Is that kind of the idea? Y'all gonna do a poll whether this will work? This sure is hot. The middle's already messing up. Should I stop? You see the middle doing something weird? Is it air gaps or what? This is burning my freak out of my hand. Continuing. Concentrated heat in the middle is causing that. Okay, so I'm trying to stay on the edges now. A glove would help, yes, that's very smart. Gosh, I'm gonna get third-degree burns. Okay, we have melting going. We have picture! Come on. We have picture! Come on, keep going! Keep going! Keep going! You can do it! Oh. We're good? I think we're good. Oh. Oh my gosh. My hand's hurting. From holding pressure. Try to keep holding pressure there because I don't want it to pop up and warp and pull the thing off. Oh. How do we do, Andy? Yeah, I'm ordering some heat-resistant gloves right now. Because that was some pain. Only third-degree burns, though. For a system I'm not even getting paid for. How did those 100-degree tweezers feel? Yeah, exactly. The tweezers actually didn't get as hot as I would think. But fourth ball from the bottom right. Ceramic tweezers, yes. So I think I need ceramic tweezers. I need gloves. And I need to not do this ever again. That all works together too. All right. Okay. Yeah, I'm missing a ball, I think. Okay, well, we can always replace one ball. I'm not worried about that. Dry paste. Okay. It actually looks. I'm pretty happy. Let's see here. Okay, let me get an angle here. Oh, the ball popped out. It just kind of blew out of the hole. That's cool. We can actually save that ball, right? So that's not a big deal. We can put that ball back on there. Missing a ball there. Okay, so we're missing two balls. Could be worse. Could be worse. What do you think? I can't believe. Oh man. 98% is pretty good. Okay, so I need to save this ball. I don't know if I have any more around here. We didn't save any other ones earlier, did we? We might need to make some. We'll save that guy. Or should I stick him back in there and melt him now? I would just rather do it later. Right? Just save him. But we need one more. We need one more ball, I tell you. One more ball. Right there. All right, let's get the stencil taken off. New gloves for Christmas. Yeah, I have a lot of work gloves. This is a joke, but do it later. Stencil off. Okay. Pop the stencil off. Slowly. Now, I don't know how well this is going to come off. That's the question. But we will see. We don't have any balls passing through, so I'm just going to come off. You're just going to come off? And what's your trick on getting it off of here without pressing too hard and making sure we mess up something? Do you reheat it again? It's probably too cool now. Yeah. Okay. Should I add some more flux and heat it up, or just remove it while it's still hot? Okay. We'll heat it back up a little bit. Alright, I see another pad. Three balls. Alright, so we have this one we can put right there in this little happy little place. Right there. This one we need one there, and then we need. We have some extra ones over here. They're tiny. And that's not one. And then this one's missing, or it's kind of a low ball. I don't know how we're going to go with that low ball. Back it up. We got to find some balls somewhere. Oh, should I just use some pre-made balls? Oh, yeah. What are these? Like a Here's a 0.3 wire, solder wire. So here's a 0.3 solder ball. You see what size that is comparatively. Check the stencil. Oh yeah. I have one in the stencil. There's one. Right there. There we go. Where'd you go? Just drop off. Got him. We're gonna put him right here. Okay, he's in the right spot. So we have two of them in the right spot already. And we just need one more later. Just gonna get all this extra stuff out of here. Alright, I'll deal with those two first, and then we'll come back and do this other side. I think it's a good game plan. Now, should I put this chip on the preheater? Or should I just do it in the stencil holder? I feel like I want to do it on the preheater. Let's see, do we have any more in here? It's getting lunchtime. Getting a little shaky. I've been going for 3 hours. We don't have any more in there, so I'm just going to have to steal a ball out of one of these. Suggest to make some balls. No preheater, just flux and flow. Okay. Yeah, I can make some balls. If this ball's close enough in this jar of 0.3s, then we'll just go with that. So. Let's see what size these are. Oh, those things are tiny. 0.3s are way tiny. Look at that. Those are 0.3s. Look how big, tiny those are. So what size are we doing? What size is that size? Can you tell? 0.45? Yeah, I'll go with 0.45. So 6, 5, 2, 2, stencil usually has a size. Well, the stencil says 0.3. That's why. I'm like, I went 0.3. So here's 0.5 and then our 0.45. So 0.45. You know, but you can never trust these cheap Chinese stuff sometimes. So we got. Okay. Oh, it looks pretty good. Yeah, that looks close. 4.5 looks pretty close. Now this thing has like a little bit of a bulge on it, which I don't like. That pad doesn't. So that might be too tall now because it already has some solder on it. I don't know how well I can look at that. So the issue I think I'm seeing is that there's already solder on here. And so like the ball's about the right size, but there's a little bit, it's like a half solder. It's almost like half of it was on the other one or something. I think I should still do it. It's hard to remove it. These are 0.45 balls that I'm putting on here. Use the smaller ones and then to add to this one maybe? Okay. Let me set this off so I don't lose it. So go back to the 0.3s that I had. Which I have. There's actually a little bit around here. What if I just use one of those? So that's like 0.4. Okay, that's my 0.4. So this is an extra ball right here. This one might be the right size. Oh yeah, that one is the right size. There we go. Found one. Got it. Okay, so now, no preheater, huh? It's gonna be kind of hard, I feel like. All right, so we got everything lined up the way we want it. We got the balls in place. At this point, we just need to heat it up and try to get all of them to sit in the right place. We're going to be vigilant on, let's see if you guys can, it's so hard to tell. See if I can get really in focus for you. So I need you guys to yell at me if I'm going wrong, or if we see something moving. Okay. So up here is that one we're going to be doing. Where is it? Right there. And then we have these other two that are in this area somewhere. All right, here we go. Why no preheater? I don't know. So we're going to do low air pressure. I usually do like a 300 on this. Does that sound about right? 300 degrees with like 30% air or... Small balls on the left. So last one. I'm going to refill it. I don't see anything that's out of place. I looked through all of it. 330. That might be a little safer to go for 330. But just low air pressure. 5% air. It seems really low. If you don't have I don't have a nozzle on this. Should I put the nozzle on? I feel like I should put like a fat nozzle. Like this, no nozzle? Because that way we can heat the whole thing. Alright, so we're at 30% air, 20% air at 330. Everyone see it good enough? We just don't want to blow any of those things around. That's the main thing. But you'll look at it, you'll start seeing them all dance into position. $330 is too low. Lead farmer? Yeah. It could be. See, I'm used to doing this on a preheater. That's the thing. That's funny. It's like whenever I'm doing stuff differently, when you do it on a preheater, you don't need much. So what should I go up to? Lead farmer. Yeah, 330 is not doing anything. I'll do the flux afterwards. That's what I usually do. Is I'll first seat these things all in the right spot, and then I'll add flux at the end. I don't want those extra balls to flow out of place. Come on, baby. With nozzle, small pressure. Yeah, I probably would use like a little nozzle on it. Okay, I get some of them. There they go. Look at it. Look at them go. Look at them go. You see them dancing? You see them all go? I'm not totally in focus or what? It's hard. It's just like there's a reflection. All right. So now we can add flux to it. If we wanted to. We're so inclined. We're good though. Now flux. So NF flux, right? NF dot flux, that's what we should be putting on it? Use some cheap flux. Yeah, that way we can just ruin everything. Small nozzle. Should we do the 213? I feel like I want to do 213 on this stuff. Golden. Yeah, we're good. We just made a new CPU. Hey, I could list this on AliExpress if I wanted to. You know? And sell this CPU as brand new. I forgot that this thing was hot. And just burned my finger. Great. Yes. The pain is coming. I can feel it. They're selling for $20. Oh my gosh. Wow. The pain is real. I'm just reflowing the flux. I have a nozzle on it now. Doing 400 degrees at 30%, I think. And I see the smoke coming up here. My finger's really hurting now. I don't know why this isn't going here. Usually I see it do a little bit more dancing. I think we're good. There we go. That's what we're looking for. Look at those beautiful balls. Beautiful balls. I'm in a lot of pain. Pretty painful. We did it, everyone. We did it. And here, look at this mess. Look at this train wreck. That's on my desk. Oh my gosh. Okay, I'm gonna sit here for a second. Yeah, I messed up my finger pretty bad. Or both fingers actually. And I can see my skin's completely wrinkled over. Wow. Just to tell you what I did. So this end here, it didn't have a nozzle on the end. And so if it had a nozzle, then I wanted to like grab it because I would know that it was hot. But what I did is I took this nozzle that wasn't on there, which was cool, and just stuck it on there, and then I went to kind of adjust it, and I put my fingers on the actual hot part here, so I kind of wrapped my hand around that whole area, and now both my thumb and finger are completely just wrecked. Oh gosh. But we have a beautiful, brand new CPU that I can list on AliExpress if you want to. See our fruit of our labors here. Look at that. Thing looks perfect. It's perfect. So now what do we do? I'm gonna go get some water to put my finger in. That's what I should do, actually. Sucks, man. Oh, okay. I'm gonna take a drink of water. Yeah, you feel the pain, never use water. What am I supposed to use then? I got burn cream at home. I don't even have it here, which is funny. Running water. Sorry, ice bath, yes. Yeah, these are the pain's starting to increase right here. Here's what I'm gonna do. I think that we're just gonna stop. Because we got the we actually succeeded in what we were trying to do. Well, kind of. We made the CPU now. It took us, what, 15 minutes to get the CPU off, and then it took us still 3 hours to actually make it usable to put on something else. So now we have a CPU. Do you want me to continue this on Wednesday, installing it, or should we wait till next Sunday, since a lot of people tune in on a certain day, and we can continue this next Sunday, installing it and testing it and things like that? What do we think? So, here, I'm going to end this poll here. So the question would be next Sunday. I think next Sunday would probably be more practical because most people, there's certain people who tune in on Sundays and certain people who tune in on Wednesdays. And so, okay, so here's what we're going to do. We're going to bench it. I'll save this for next week, or next Sunday. And so next Sunday, we're going to proceed with installing this onto the other motherboard and seeing if, and then that way I'll have time to actually have some. I don't have the laptop to fully install into, so I gotta go find a test machine, and that way we can get it installed. And either way, this thing was pretty sick. Oh, we got a new cool fan member. This is that looks pretty legit though. That looks pretty legit. And so now I know the process on how I want to do it. And yeah, it was pretty good. I just saved my fingers! No, I just burned it. Heck out of my fingers! Well, do you guys want to just chat for 15 minutes or so? Ask your questions. I know it's been a long stream already, it's been 3.5 hours, but I usually like to have a little bit of time at the end to do a questions and answers or just chatting thing. Yeah, I'll live through this. When I get home, I'll put some burn cream on it and we'll be good to go. Oh, next Sunday. And I need to get mittens. That's what everyone's saying. You know what? If I had latex gloves on, do you think it would have been worse? If I would have actually had my latex, or nitrile, I guess. Would it like burn to me? No, stop the stream, care for the skin. Okay. Alright. I appreciate that. You guys are so thoughtful. Everyone's so thoughtful. You watch stream every Wednesday evening for the first time. You usually watch on Wednesday. It was like it was bought brand new from Intel. That's how good it looks. Neosporin. I thought Neosporin, isn't that a myth? That stuff I heard? I don't know. No chat, fingers first. Okay. Well, then I will, because I'm actually hungry too. So I'll go have lunch, clean up my mess. Look at this. Look at this. This is nuts. I need to get some better paste though. So if someone can Discord me, get me some heat-resistant gloves. Thanks for the super chat. Colin says I need to get some heat-resistant gloves. Nitro would have been worse, yes, so that's why I don't worry about it anyway. But yeah, so someone can tell me or send me what they use. Andy, that would be nice if you can tell me what you use. Or I need to dry it out really well. I really would love to have really dry thermal paste. Leave the lid off. There's your problem. Just leave the lid off. So I just leave it off like that, and we'll be good to go by next Sunday. Oh, it's starting to look funky. Okay. All right. Well, I'm going to sign off. I appreciate each and every single one of you. Thanks. Use Mechanic 183. So, okay, so I need to order Mechanic, not Wonderway. You don't think Wonderway is good? Whenever I saw the word Wonderway, I was like, this gotta be stuff. This has gotta be stuff. Anyway, yeah, I'll order some more stuff for next week, and that way we have Wonder Why. But anyway, I want to thank our mods who work really, really hard every single week to keep everything going. I want to thank Andy over at Window. I'm gonna check out your channel. He does console repair. He'll help us on this. And thanks for all the super chats and all the subscribers and members and all that fun stuff. And I'm gonna go home and take care of my fingers. And thanks for watching.
like we were black at one time and came from Africa. Yeah, I think that's bullshit too. like that.